algorithm workbook, I am explaining chapter number 1. Right? Let me explain. I think, see, without my explanation also mostly you are comfortable. Right? The chapter contain almost like 40 questions are there. Right? Mostly every problem you are comfortable. At one or two places if you have doubt, let me explain, most probably those doubts also will be cleared. Right? Listen my explanation. Mostly you are okay. Listen my explanation also. Finally you will be right little bit more comfortable than the previous one. Right? Let's start one by one. Let's go to the problem number 1. Chapter number 1, problem number 1. What is the problem number 1? Right? One program is given. They are asking what does the following algorithm approximate. So they are asking what does the following algorithm approximate means. They are not asking time complexity. They are asking, right, this program, if you observe, what is the last line? Print x. Indirectly they are asking that this program output approximately what. Now from this problem you have to learn one thing. What is that? By seeing program, don't think that it is the time complexity. By seeing this program, some people are thinking that program and some log n m square is there. They are thinking time complexity. No. What they are asking also, please see. This is the most probable mistake what right computer science people are doing. They know how to find out time complexity. By seeing program, they will give time complexity. No. Right? So let's see what they are saying. What is that one? What does the following algorithm approximate? Nowhere time complexity there. Right? What does the following algorithm approximate? If you see program, what is the last line? Printf. Okay, approximately what this algorithm is printing. That's the thing what they are asking. So indirectly, directly, what is this program output approximately? How to calculate, I will explain. And one more, one very, very important point I am saying, please listen this. Right? The purpose of explaining this workbook is mostly to say this point only. This is a very, very important point I am going to explain now. Please listen. Please listen. One program is given, they are asking what the algorithm approximately will print. That is also okay. Right? So whenever they will ask like that, right, there is something going on in the while loop. Don't think what the logic inside. For every problem, no need to find out what is the logic inside. Right? So one program is given, this program output what they are asking, or this program time complexity what they are asking, something like that. One program is given, they are asking what this program is printing. What this program is printing, they are asking. Right? Then what will you do? Don't think about the logics and all. What exactly internal logic? Don't see. Worst case, you can think about that also. Right? Sometimes really not required. Some people are asking, sir, when really not required? Nothing there. See the option. If the options contain, if you see the options are there mathematically or asymptotically. If you see the options are there mathematically, not asymptotically. What is meaning of mathematically? Mathematically means exact values. Asymptotically means constant doesn't matter. Mathematically means exact values. I think they are given one program, they are asking approximately what this algorithm is printing, and options are given mathematically. Mathematically means 5 is different, 7 is different, 10 is different, 20 different, but asymptotically all are same. Try to remember, options are given mathematically. Right? Don't think that much about what is the logic inside this program. Please try to substitute values. Because whenever logic is important, think about what is going on inside. Really logic not important. Worst case, you can think about logic also. Options are given mathematically. Please go through substituting the values. You will get most probably answers easily. From today onwards, you remember, right? Any program is given in GATE exam or any exam. They are asking, right? What this algorithm is printing and all. What this algorithm is printing and all. If options are given mathematically, then substitute the values. Don't think about the logic. Substitute the values. Some people are asking, sir, how to substitute and all. Right? Let me check here. So I am checking. See carefully now. Right? Let me check here. And one more. I decided to substitute the values. That's okay. If you substitute the values, can you help? Options are given how? I think log m, root m, m square, m power 1 by 3. So what is the meaning? Take some m value. Finally, what is the answer coming? I have to check. Suppose assume that, right? One more suggestion I want to say to you. You have to substitute values. It's okay. Right? See the option. In the options, if you observe, right? You have to take some m value. Right? Answer coming how? We have to verify. That is also okay. But don't take the m value where two options will give same answer. So select some m value where options will be different. Options will come different. Some people are asking, sir, what is the meaning of this? You only say, right? Let me ask you one small line now, right? What is the log 10 base 2? Isn't that m value 10? What is the log 10 base 2? I think approximately log 10 base 2 is 3 point something, right? If I say root 10 also 3 point something, because of both are same, right? Again confusion. So the best idea is going to be, right? See this one. Any program is given, if they are asking what is the output of this program, right? Don't think that much about the logic, right? If options are mathematically, right? And some people are without logic how to solve. By substituting values you can solve. The next one is going to be, while substituting, don't take blindly some number and don't substitute, right? Before substituting you have to take care one more also. Substitute that value where, right, 4 options whatever there, they will give different answers. If I substitute 10, A also giving 3 point something, right? C also giving 3 point something. So again, right? Other options may not fight. I think A and C again fighting. Again you have to take one more m value. What is the best idea? Starting itself, you make sure that substitute some m value which will give different answer for all the option. Let's substitute, right? M value assume that 100 I will substitute. M value 100. Otherwise, if you want, you can take 1000 also. Assume that m value 1000. M value 1000. So I am starting. See this one. Question number 1. Question number 1 answer I am trying. Right? Question number 1 answer I am trying. See this one. M value 1000 you try. M value 1000. Right? Let's check one by one. See the options. Go to the question number 1. See the program now. M is 1000 I took. So what is the answer expected? Let's check here. Can you help me now? What is the program? See the program. X is equal to m. X becomes 1000. Y is equal to 1. That is also okay. And one more, epsilon is greater than 0, that is also okay. Now start, while loop is going on. What is the answer? X value 1000, Y value 1. 1000 minus 1, 999 is greater than 0 or not? True. Then go inside. What is the answer? X plus Y. What is the answer? 1001 by 2. 1001 by 2. Then what is the answer? 1000 by 2 is 500. 1001 by 2. What is the answer? 500 point something. Right, let's take all as integers only. That is the reason is given approximately. Don't think little bit about minus 1 plus 1. So 500 by 2, sorry, 1000 by 2, 1001 by 2, which is going to be approximately 500. X becomes 500, right? Y is equal to, what is the answer? 1001 by 500. How much? Right, 1000 by 500. What is the answer? So this will become, so what is the answer? 1000 by 500 is going to be approximately 2. So X value becomes 500, right? Y value becomes 1000 by 500, which is going to be 2. So I think 502. So can you say initially what is the X value? 1000. Y is 1. After one round over, what is the answer? X becomes, right? X becomes 500. Y becomes 1000 by 500. What is the answer? 2 maybe approximately. Approximately, don't bother about plus 1, minus 1. Next, while loop is going on. What is the next row? X minus Y. 500 minus 2. What is the answer? 498. Greater than 0, true. What is the next row? X is equal to X plus Y by 2. 500 plus 2. Right? 502 by 2. What is the answer? I think approximately what is the answer? X value becomes 250. Right? 250. Actually, the 502 by 2. Right, what is the answer? 2 2s 4, 2 5s 10, 2 1s, maybe 251. If you want, I will write 251. Can you say what is the Y value? Y is equal to, what is the answer? Y is equal to, what is the answer? M by 2. What is the M value? Y is equal to M by 2. Is M changing again and again or not? In this loop, M is not changing again and again. Right? Can you help me now? What is the Y value? Y is equal to M by 2. What is the M? Initially, what is the M? M is equal to here 1000. M is equal to here 1000. So I think X value becomes 1000. Y value becomes 1. After one time is over. X plus Y by 2. What is the answer? 1001 by 2. It will become 500. Y is equal to M by X. M by X. What is the answer? 1000 by 500, which will goes to 2. In the next round, if you see x is equal to x plus y by 2, I think 502 by 2, what is the answer? 251. Y is equal to m by 2, what is the m? 1000. 1000 by 2, what is the answer? M, y is equal to 1000 by x, sorry for that, 1000 by x, what is the answer? Previously 1000 by 500, now 1000 by 251, approximately how much? Approximately how much? 1000 by, right, 1000 by 251, what is the answer? Approximately 4, right? So, that is the reason approximately is saying don't bother. Next one, can you help me, what is the next round? X is equal to x plus y by 2, right? 251 plus 4, 255 by 2, what is the answer? 255 by 2, what is the answer? 2 12s, 24, 1 there, 2 7s, 14, right? Approximately 127, every time half going on. Can you say what is the y value? M by 2, sorry, m by x, what is the answer? I think 1000 by 127, approximately what is the answer? Isn't that 125? 125 into, what is the answer? 8. So 8 5 is 40, 8 2 16, I think 20, 8 1 is 8 2. 8 1 is 8 plus 2, 10, I think 1000, right? Same story. What is the answer? 8 will be there. I think the powers of 2 increasing, 2 square, 2 cube, like that. It is also decreasing by always by 2, by 2, by 2. So it is going on. Can you help me know what the next one? Right? X is equal to, what is the answer? X is equal to, again x plus y by 2. 127 plus 8, what is the answer? 133 by 2. What is the answer? 133 by 2. Approximately. How much? 133 by 2. What is the answer? I think 2612. 2612.5. So approximately 66. What is the y value? What is the y value? M by x. What is the 1000 by? 1000 by. What is the 125? Approximately 65 maybe. Approximately 65. If you do that, what is the answer? Right? So if you divide by 65, what is the answer? Previously divided by how much? Right? I think it is going to be, I think if you observe clearly, it may be 16. Right? Approximately same 16. Right? Like it is continuing, something like that. Right? Can you help me now? If you do that, what is the answer? X value becomes next round. What is the answer? X plus y by 2. 66 plus 16 by 2, how much? 66 plus 16 by 2, how much? Which is going to be 76, 82 by 2, what is the answer? 41. 66 plus 16, which will goes to 76, plus 6, 82 by 2, approximately 41. Actually, half of this one is going to be maybe 40, half of this one is going to be 32, something like that. It is game 41. Assume that. Assume next minor changes. Y is equal to what is the answer? Y is equal to what is the answer? Right? M by x. What is the answer? 1000 by 41. 1000 by 41. So what is the answer? I think this may become, so what is the answer? If you want, you can check approximately it will goes to the double again, 32 maybe. 32 maybe. Let's check here. 41 into 32. How much approximately? Right? If you can multiply both of them, 4 3 is 12. Approximately like that only. Continue like this one. What may be the next one? X plus y by 2. 41 plus 32. I think 73 by 2. What is the answer? 35 approx. Y is equal to, what is the answer? M by 35. What is the answer? M by 35. It may be 64. So assume that I continued here. If you observe clearly, the 41 32, this is going to be 35 64. 35 64. I think if you see the while loop, x minus y is greater than epsilon, but it is fail. Right? You can stop here. Can those people who are having small doubt also, right? Just to take some m value, take little bit bigger, right? I said to you how to select also. No two options will give the same answer. Select m value in such a way that, right, no two options will give same value. So I think just I continued the while loop. Calculate properly. If you want, you can calculate. Because of he is given approximately, I took the approximate values. Continue like this one. Always, right? X is equal to x plus y by 2. right? That is the thing what is given, right? Y is equal to m by x, right? Approximately I calculated. Continue, x minus y is greater than epsilon, right? Whenever that is fail, see this one, x minus y greater than epsilon, fail, stop. At that time what is the answer? Print x. Print x. Can you help me now? If I say print x, what will print? Approximately 35 will print. Approximately 35. So what I want to say indirectly, directly to this problem, see this one. For the problem number 1, if I give m as 1000, what is the answer printed? Approximately 35 printed. 1000 if I give, approximately 35 printed. Maybe 35, maybe 32, approximately like that. Right? Now some students are asking, 1000 is given, 35 is printed. So what is the answer for this? Now check here, options. Can you help me now? What is the log 1000? What is the log 1000 base 2? What is the answer? 1000 can be written as approximately 2 power 10. 10 will come. If you take the bigger base, I think it will become less only. So option A cannot be the answer. Right? Can you see the option B? What is the option B? 1000 is given. 1000 is given. What is the root 1000? Right? It is not asking cube root. I think it is asking root. What is the answer? Everyone know. Everyone know. So for the 1000, what is the root? I think 30 into 30 is 900. Maybe approximately 32, something like that. Please check properly. Right? Please check properly. I think root 1000 is going to be approximately 32 or 33, whatever it is. Right? This is the answer for this. What about the option B? M square. 1000 is given. Right? It is not, x value is not 1000 square. Right? Next one. M is, I think option B is going to be, right, root 1000. Sorry, cube root of 1000. I think cube root of 1000 is only 10. So closest answer is going to be, right, root. So can you help me one small line? For the question number 1, what is the answer? Question number 1, C will be the answer. Now I want to clarify one thing. Question number 1 answer is going to be option C. The reason how I done is, right, whenever any program is given, from this one please learn. If you keep on thinking about what logic is going on, right, you have to take care about logic. I am okay with that. For everything, no need to think about logic and all. Necessary places you think about. Even I don't know what is going on. What is going on here? Always x plus y by 2 you will do. M by x you will do. Continue. He is not continuing until last place also. See the interesting thing. He is not continuing in this problem until x value becomes decreasing. X is decreasing, y is increasing. X is decreasing, y is increasing. Right? Until termination condition is not going. But here what is the termination condition? Termination condition is normally until 1 will come, he will go. But it is not the termination condition. X minus y is greater than epsilon. That is the termination condition here. So if you keep on thinking about logic, right? So this problem may take a lot of time. What is the best idea? Take some m value, substitute. You can take the m value very small also, then confusion will come. Whenever m value very small, root m and one more thing is log m look like same. Let's take little bit bigger number, then you will get the clarity. The advantage with the problem number 1 is going to be, I explained 2 important points. What is the one point? By seeing the option, you have to decide. You have to think about either logic or substituting values. Because the options are given mathematically, right? Substitute values. And one more, while substituting, don't substitute blindly, right? Substitute that value which will differentiate the options. These 2 things are main. By seeing program, if they are asking something, don't think the time complexity. Read the problem properly. Okay, what does the following algorithm approximate? It doesn't mean that time. Right? By seeing this one, okay, approximately what this algorithm will do. Okay, lastly printf also there. So indirectly is asking this algorithm approximately what it is printing. And one more, by seeing this one, don't think about logic. Think about options. Options are given mathematically, okay, substituting values. While substituting, don't substitute blindly, substitute that value which will differentiate the options. I took the m value 1000, that may be the reason it is taking a lot of time. Right? If you want, take the m value 100 also. What are the log 100 base 2? I think 100 can be written as 2 power 6, something like that, or 2 power 7. So 7. Right? Next one. So listen everyone now. Listen correctly now. Right? Log 100 base 2 approximately 7. Root 100 is going to be, what is the answer? 10 into 10, 100. So I think 7 and 10, which is very close. Because of approximately, both are almost similar. That is the reason I am not taken 100 also. Take some big number. You always remember, here time is not important. Correct answer. take little bit of extra time, right? If possible, try to give the correct answer. So for the question number 1, our answer is going to be C, right? Please take care from now onwards, right? Options are given mathematically, substitute the values. Many questions are there like this, that is the reason I am explaining again and again, right? Question number 1, answer is going to be C. What is the question number 2? I think nothing there. Question number 2, if you observe, right? What is the answer? One loop is going on. Can you help me now? Question number 2, what is the initially J is asking lastly J value. Question number 2 is asking, right, last to J value. Last to J value. Can you see initially J value? Initially J value 0. What is the next? J is equal to J plus I. I is, I think, keep on divide by 2, by 2, by 2, by 2. I is initially N. So for the J initially N will be added. Next N by 2 added. Next N by 4 added. Always by 2. I think this may be the case. Right, question number 2 I am writing, this may be the case. Right, J is equal to, right, J plus 0 plus I keep on changing. Whenever this loop is going on, I also changing. Initial I N, next N by 2, next N by 2 square, and so on. It will continue always by 2. N by 2 power log N. Right, which will goes to N common, 1 by 2 plus 1 by 2 square plus 1 by 2 cube plus, and so on. Right, 1 by 2 power log N. Which will goes to what is the answer? N, because of the decreasing GP series, order of 1. Please check. So finally answer is going to be order of N. N is the answer to this problem, right? For the question number 2, what is asking? Let the value of J denotes the value stored in the variable J after termination of the for loop. Which one of the following is true? What is the answer? C. C is the answer. He is given theta, because of all are theta only, you don't bother. Theta means what? Big O also, omega also. So val of J is equal to theta of N. For the question number 2, answer is N. Which one? Option C. Let me write here. I written already. Right? Question number 2, answer is C. That is okay. Go to the question number 3. Question number 3. Question number 3, what is the answer? If you see this program, maybe it is there in your notes also, I don't know. Question number 3. Let's check here. See the question number 3 also. If you see the question number 3, assume that prime of N is prime of N time complexity Tn, assume. Question number 3 I am talking. Is prime of N time complexity Tn, assume. I am repeating once again. Is prime of N time complexity, assume that Tn. Right? What is the Tn? We will see within few minutes. Right? Tn is equal to what? Can you help me now? Whenever this program is going on, is there any for loop? Yes. That loop is how many times? Square root of N, means root n times. There is a for loop which is going on root n times. Next one, right? There is a loop which is going on root n times, it's okay. But inside the loop, if you observe, what is the answer? N modulo I is equal to 0. N modulo I is equal to 0. Can you say what is the initially I value? 2, next to 3, next to 4. So every time N will be divided by I. At anywhere remainder 0. Then what is the answer? Just print a prime, it is not a prime number and stop. I think he checking given number is a prime number or not. If any number, see this one, N is having one factor also. From 2 to less than N, if N is having one factor also, it is not a prime number. So what is the answer? This loop is going on root n time. Whenever this loop is going on root n time, at anywhere N having factor, stop and say that it is not a prime number. Suppose assume that whenever this loop is going on, nowhere one factor also there. At the end of the loop, right, return 1 means prime number. It is simply checking given number is a prime number or not. It's simply, right, given number is a prime number or not. This program is for checking given number is a prime number or not. Loop is going on 2 to root n times. 2 to root n times. Right? So if at all assume that given number is a prime number, then what is the answer? One factor also will not be there. This loop will repeat root n times. Suppose assume that n value assume that 50. What is the answer? 50 modulo 2, 0. Then not prime number. So what I want to say, this algorithm, right, will stop sometimes immediately. So what is the answer? Minimum time is it will take 1. Maximum time is root n. This algorithm, can you help me one small line now? Tn is what? Time complexity of this algorithm. It is having two values. Time complexity of is prime of N is Tn. It is having two choices. What is that one? Sometimes it will take constant time. Sometimes this Tn will take constant time. Sometimes it will take root n time. This Tn having two choices. Tn having two possibilities, 1 also, root n also. Now can you help me now? This Tn having two possibilities, right? Sometimes it will take 1, sometimes it will take root n. What is the technical way of writing? This way you can write. See this one? Tn is, listen, Tn is, right? Big O of root n. Can you help me? What is the meaning of big O? Big O means what is the meaning? Comparing Tn, root n will be bigger or equal. Everyone know. Tn, one of the possibilities root n. Root n is big O of root n. Tn, one of the possibility 1 also. 1 is big O of root n, then also true. Same thing, Tn having two possibilities. Sometimes 1, sometimes root n. What is the meaning? Tn cannot go less than 1. Tn cannot go more than root n. What is the Tn bigger value? Root n. Tn less value? 1. So same thing, technical way of writing. Comparing Tn, root n is bigger or equal also, it's the big O. And one more thing, and what is the answer? Tn is omega of 1. What is the meaning of omega? Tn is bigger. Can you help me? What are the Tn possibilities? It will be either 1 or root n. If at all root n is omega of 1, true. If it is a 1 is omega of 1, that is also true. That is the answer. This algorithm having two possibilities. Sometimes it will stop immediately, means constant time. Sometimes it will go until root n. So this algorithm will take minimum 1 time, maximum is root n. Right? Technical way of writing, minimum 1, this. Maximum is root n, right, like this. So can you help me now? For the question number 3, what will be the answer? Right? So this algorithm will take maximum is root n, upper bound, everyone, big O means upper bound. This algorithm will take maximum is root n, right, everyone, omega means lower bound. Lower bound means something like minimum. Upper bound means something like maximum. Tn having two choices, sometimes 1, sometimes root n. When 1, if the given number is not prime number, you may stop immediately. If the given number is a prime number, you may go until root n time. It is having two choices. Minimum it will take 1. Maximum it will take root n. Right? So maximum, upper bound is root n. Right? Lower bound is 1. Right? Fine. Anyhow, forget about upper bound, lower bound concept. Tn having two choices. Tn having two choices. Sometimes 1, sometimes root n, which is nothing but this Tn cannot go less than 1. This Tn cannot go more than root n. It cannot go more than root n, like this. It cannot go less than 1, like this. Forget about upper bound, lower bound. This Tn having two choices, 1 and root n. This Tn cannot go less than 1. This Tn cannot go more than root n. More than root n, it cannot go upper bound. Less than 1, it cannot go lower bound. Right? Something like that. So can you help me now? For the question number 3, what will be the answer? B, second option. Question number 3, second option. Right. Fine. Try to get as maximum as possible. Go to the question number 4. One program is given. They are asking the return value of the function is. And one more. Question number 4. One program is given. They are asking return value of the function is. That is also okay. But one thing, by seeing program, don't say time complexity. Whatever they are asking, that only find out. Program given. They are asking return value of the function is. Means he is asking return value means what is the last line? Return k value we have to compute. And one more, you cannot substitute also. It is not time complexity because of he is saying return value, that is okay. And one more, by seeing options I can say, right, you cannot substitute also. It is not mathematically, it is the asymptotically. Asymptotically means logic is important. What is the meaning of asymptotic notation? Saying small things don't bother. Small things don't bother. Think about logic. What is the meaning of mathematically? Mathematically means everything you have to bother. Asymptotically means logic matters. Mathematically means everything. At that time you can substitute also. Now I cannot substitute because options are saying that asymptotically. Right? Now compulsory you have to see what is going on inside. If the time complexity value doesn't matter, compulsory logic you should know because he is given the option asymptotically. Right? But one thing in this problem he is asking return value of k. Let's check here. I think two loops are given. Can you help me now? I loop is going on how many times? I loop starting from n by 2. I loop is starting from n by 2. Every time plus. I think I loop is going on n by 2 times. N by 2 onwards starting, always adding plus 1. One more n by 2 times it will go. So I loop is n by 2 times. Can you say j loop? J is equal to 2, j less than or equal to n, j is equal to 2 into j. I think always increment, always multiply by 2. I think j loop is log n time. I loop is n by 2 time, j loop is going to be log n base 2 time. Can you help me now? Each j value, what is the answer? K is equal to k plus n by 2. What is the initial k value? 0. Right, 0 plus n by 2. I think whenever j loop is going on, k contain, right, always adding n by 2, always adding n by 2. J loop is going on how many time? Log n time. Every time is n by 2, n by 2, n by 2, n by 2. So what is the answer? N by 2 times log n. So I think after completion of the I loop one time, after completion of the I loop one time, right, j loop is complete j loop. J loop is complete how many time? Log n time. Log n times n by 2. So n by 2 log n by 2 log n. I value 1, n by 2 log n. I value starting I value, what is that one? N by 2. I value n by 2, right, n by 2 log n. I value n by 2 plus 1. What is the answer? 1 more n by 2 log n. 1 more n by 2 log n. Continue. How many times? This is the case. So can you help me? Question number 4. Question number 4, what is the answer? I is going on n by 2 times. J loop is log n times will go. Every time you are adding n by 2. So at the end of the I loop one time I loop is over. Log n times n by 2 plus n by 2 plus n by 2 log n time. So n by 2 into log n. This is happening n by 2 times. So finally what is the answer? Finally what is the answer? N by 2 into n by 2, what is the answer? N square by 4 log n base 2, which will goes to n square log n. This is the question number 4 answer. See this one, question number 4, what is the answer? N square log n. Why? I loop is going on n by 2 times. J loop is going on log n time. Every time k value you are adding n by 2. First time n by 2. Second time also n by 2, means 2 times n by 2. Third time also n by 2. 3 times n by 2. Right? If you continue log n times n by 2. So I value n by 2, this is the story. I value next I value once again same. Next I value once again same. So n by 2 times this much. So n square by 4 log n base 2, which is nothing but, forget about constant, n square log n. For the question number 4, what will be the answer? N square log n, which is going to be second option, B. Question number 4, second option. Now go to the next one. Question number 5. It is there already in your notes also. Please verify. What is asking? Question number 5. Check once. Which one of the following most closely approximate the return value of the function 1? One function 1 is right. One function is given. Name is function 1. Fun1. Is asking which one of the following most closely approximate the return value of the function fun. Means finally is asking this function approximately returns what? This function, right, approximately returns what? So can you help me know what is the function name? Fun1. Right, how many loops are there? 3 loops. How many loops are there? 3 loops. For the I, inside j and k there, but j and k is not inner loops. For the I, j and k is inner loop, but for the j, k is not inner loop. So in this problem, if you observe 3 loops are there, but j and k loop is inside I. J and k is inside I. Now can you help me one small line? I loop is how many time? Always plus I. I loop is how many time? N time. I loop is n time. Can you help me now? J loop is how many time? Always by 2. What is the answer? Log n. Can you help me now? K loop is how many time? Always into 2. K starting from 1, always into 2. That is also log n, something like that. Can you help me? Again I am repeating now. I loop is how many time? Always plus 1. I think I loop is n time. I loop is n time. Can you help me now? J loop. J loop is how many time? Always by 2. What is the answer? That is also log n. But one thing, J loop is always by 2. That is fine. Right? How many time? J loop is log n time. Every time plus p. Every j value decrementing, p value incrementing. So can you help me? J value decrementing how many time? Approximately log n time. I think p becomes log n. Can you help me? What is the k value? K is always into 2. It is also log n. K loop also log n time. Right? If the p is n, whenever k loop is going on, before k loop what is there? J. J is over means p value becomes log n. J value over means p value becomes log n. Whenever k loop is going on, k loop is going on how many time? Always into 2 into 2 into 2 log n time if at all p place n there, right? But because in the place of n p there is a log p time. I loop n time, j loop log n time, k loop log p time. What is the p? Log n. So k loop is going to be log n time. K loop is going to be log n time. And one more thing I want to ask you, I value 1. Can you help me? Whenever k loop is going on, how many times k loop is going on? Log p time. What is the p? Log n. So k loop is going on log n time. But k loop is going on log n time, it's okay. But each k value plus q. So k value 1 plus q. K value, next one is going to be 2 plus q. Every k value plus q. Can you see how many times k value? Log n time. So q also becomes log n. So I value 1, q value becomes log n. I value 2, k value becomes one more log n. I value 3, q value becomes once again log n. How many times? N time. N times log n. For the question number 5, answer is going to be n times log n. Which option? Fourth option. N times log n. Can you say j loop? Log n time. Every j loop is log n time changing. So p value becomes log n. K value changing log p time. K value changing log p time. So q value also becomes log p for I is equal to 1. I is equal to 2 also. One more log p. I is equal to 3 also. One more log p. So like that a q value keep on increasing. I value 1 over. Q value becomes log n. I value 2 over. Q value becomes 2 log n. I value 3 over. Q value becomes 3 log n. I value n is over. Q value becomes n log n. So answer for this problem n log n. So problem number 5 answer is going to be D. Right, fine. Please you take care all. I given enough time to you to verify. Right, first see all the video lectures whatever I given. First see that. First see all. Time complexity purpose approximately 20 problems I said. With that easily you can handle this. But still I am explaining workbook also. You cannot say that sir is going little bit fast, sir is going little bit slow. Right? You cannot say that. Right? Mostly you have to handle by yourself. Problem number 6. So problem number 6 if you see, one program is given, they are asking what is the time complexity of this program. So can you say how many loops are there? Time complexity and one more options are given asymptotically. So you have to think about the logic. See the logic inside. I loop is how many time? N time. J loop. So in the J loop if you observe, every time if I add plus 1 n time. If I do every time J loop plus 2 n by 2 time. If I in the J loop if I add every time plus 3 n by 3 time. He is doing every time plus I. What is the meaning? N by I time. I value 1, J loop is going on n by 1. I value 2, J loop is going on n by 2. I value 3, J loop is going on n by 3. I think this loop is like that. Which problem it is? Problem number 6. Right? See this one, problem number 6. So I think it is going on like this one. I value 1, J loop is n by 1. I value 2, J loop is n by 2. I value 3, J loop is n by 3 and so on. What is the last one? N by n approximately. So n common remaining 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by n, which will goes to n. Every one of this series is log n series. N log n. Answer is n log n. For the problem number 6, answer is n log n. Which option? I think C. For the question number 6, answer is C. Right? Go to the question number 7. Right? Go to the question number 7 here. So question number 7 if you observe, what is the Fn? Question number 7 if you observe, what is the Fn? 3 into n power root n. What is the Gn? 2 power root n log n base 2. What is the Hn? N factorial. Right? Now see this one. It is the 3 into n power root n. It is the 2 power root n log n. Everyone know. In the power, carefully listen. In the power log is there. In the power log is there. You can apply this formula. What is the answer? Right? So this one, I think these two you can exchange. It will become, what is the n power root n log 2 base 2. In the power log is there, that formula. What is the formula? This one. N power log a base b can be written as a power log n base b. These two you can exchange. Right, same thing. I think if you do this one, it will become n power root n. This is already n power root n. It is already n power root n. It is n factorial. Everyone n factorial, what is the closest upper bound? N power n. Right? N factorial closest upper bound is n power n. Now can you help me one small line now? One thing is to comparing n factorial and n power n is bigger, okay. Right? But one thing, these two are little close. It is the n power n, it is the n factorial. First it is bigger. Right, afterwards it is bigger, afterward this may be n power root n, it is n power root n. This is almost close to n power n, closest upper bound is n power n. Now can you help me now, right? I think fn gn, what is the answer? Both are equal. Fn gn both are n power root n, but that is almost close to n power n. Now can you help me now? These two are equal, h of n is bigger. So what is the answer? Fn is equal to gn. Right, comparing these two, what is the answer? H of n is bigger. Now can you help me now? For the question number 7, what is the answer? Fn gn both equal, right? H of n is bigger. So which option it is? Which one of the following is true? Option A, H of n is big O of f of n, no. B, H of n is big O of g of n, no. C, g of n is not big O of f of n, no. D, f of n is big O of g of n. I think answer is going to be D. Question number 7, answer is going to be D. Answer is D. Right. Go to the question number 8. Right, question number 8, let me write here. Problem number 8 or question number 8, whatever it is. If you see the problem number 8, what is the answer? Fn n square log n. Gn. What is the Gn? N log n whole power 10. Fn is n square log n, Gn is going to be, right, n log n whole power 10. Now they are asking which one is bigger, which one is smaller. Right? Before going to do that, common things cancel. What is the answer? Common things cancel. This one cancel. This one and this one cancel. Common things cancel. So what the Fn becomes now? It is n. It will become log n whole power 9. Everyone read the polynomial. It is the logarithmic. This is bigger. Fn is bigger. If you have small doubt, also apply log. After cancelling the common things, right, if you want, you can apply log. If you apply log, left becomes log n, right becomes 9 into log n. Log n and log n. Who is bigger? Log n bigger. So everyone know Fn is bigger. For the question number 8, right, let's go to the options. Who is bigger? Fn is bigger. Let's check here. So Fn is bigger, Gn is smaller, that is okay. See the option? Fn is big O of g of n, no. Gn is big O of f of n, true. But f of n is not big O of g of n. I think answer is B. For the question number 8, answer is B. Right, like this. See, this answer is B. Question number 8, answer is B, like that. Go to the question number 9. Right, if you see the question number 9 here, right, let me write the question number 9 here. I am writing. It is very simple. See the question number 9 or problem number 9. See the problem number 9. If G is big O of F, what is the meaning? G is big O of F. What is the meaning? F may be bigger or equal to G. Comparing G and F may be bigger. F may be bigger or equal also. Then see the options now. If at all G is big O of F, can I write F is big O of G? No, A cannot be. What is the B? Right, G is big O of F. Whenever G is big O of F, can I write theta of F? No, because omega may not be satisfied. So B fail. What is the C? F plus G is big O of G? No, F plus G is big O of F. F plus G is big O of F. Right, then theta also possible. Question number 9, answer is option D. Right, this is the answer. See this one, you only say G is big O of F. Indication that F may be bigger or equal also. If it is right, comparing G, F may be bigger or equal also. Then I can write like this one, G plus F. See, if it is smaller, it is bigger, right, which is equal to theta of big, you can write. because this big and this big both are, right? So I think answer is going to be for the question number 9. What is the answer? D. Question number 9, D. Go to the question number 10. It is directly from notes only. Question number 10 is going to be, what is the answer? A. See this one, I think chapter number 1, right? I think 10 questions I completed. Mostly you are okay, right? So by seeing, after listening all the lectures, mostly you are comfortable. 1 or 2 places if you have some problem, I am explaining. One new point also, if you get to see, while solving workbook, I cannot create the new things, right? So in workbook, whatever you know, those only. 1 or 2 places, maybe some positive points will come. Please you take care. Question number 10. What is the answer? A. Question number 11. Question number 11. Let's start. Question number 11. Right? Question number 11. Question number 11. What is the answer? Some functions are given. You have to write the increasing asymptotic order. Increasing asymptotic order. It's going to be very easy. You know this also answer. Let's see this one. Problem number 11. Problem number 11. Can you help me? A. N power 1 by 3. B. E power n. C. N power 7 by 4. D. C is going to be n power 7 by 4. D. N log n whole power 9. E. Right? These all 5 we have to write in the increasing order. Means I think a smaller one, next smaller, and so on, bigger. We have to write. Many people know what the answer for this one. Anyhow, let me check here. Right? Let me check. Please listen. Listen all of them. It is n power 1 by 3. Right? Just use a little bit of common sense. Right? No need to by heart anything also. Mostly you know. See this one. It is the n power 0 point something. It is the n power. It is the n power 1 point something. It is the e power n. It is the n into log n whole power 9. Right? It is going to be 1 power 0.1 whole power n. Right? Now see this one. It is the e power. What is the e value? 2.81 or whatever it may be. Right? 2 point something. Right? E value 2 point something. It is the 2 point something whole power n. It is going to be 1 point something whole power c. Both are exponential. E and B both are exponential, but it is having e value is bigger than 1 point this one. So I think see both are exponential, people are bigger. Right? In that, right, it is also exponential. It is the 1 point something. E is also growing, but I think he will grow little bit faster. I think among all of them, because of these are exponential, it is the number 1. Right? Increasing order is the number 1. Let me write here. Right? B number 1, which is going to be e power n. What is the next one? E. Right? What is that one? 1.00001 whole power n. Exponential people are bigger. But it, the e value is 2 point something, right? But here if you observe 1 point something, that is the reason this is first bigger, this is the next bigger, right? These two are clear. Exponential things I written, these are clear. Right, until now it's fine now. Let's go to the next one. Can you help now? ACD, which one is better? Let's check. ACD, which one is better? So, but one thing is to see, it is the n power 0 point something, it is the 1 point something. It is also 1 there. It is also 1 there. I think it is clearly visible. What is the answer? It is a 0 point something. It is a 1 point something. It is going to be 1 only. It is a 1. Some log n is there. That's okay, right? These two, if you have doubt, I will take care. C and D, I will take care. But one thing, it is definitely smaller. It is a 0 point something. It is a 1 is there. Here 1, minimum 1 is there. Here also 1 point something. I think smaller is A. A is smaller. What is that one? N power 1 by 3 is smaller. This is also okay. If you have any small doubt, I think these two only. These two only. I will explain now. Can you help me one small line now? It is the n power 7 by 4. How much? N power 7 by 4 means how much? 7 by 4 means how much? 7 by 4. What is the answer? 4 ones 4, remaining 3. 4 6 24, 4 7s 28. Right? 7s 28. Remaining is going to be 2, 4 4 16, 4 5 is 20. I think this one 1.75. So I think it will goes to n power. What is the answer? 1.75. This is the n power 1 only, right? Now can you cancel the common things? What is the answer? If you cancel the common things, what is the answer? This is out, this is also out. Can you say remaining? Remaining from this side, what is the answer? N power 0.75 left here, right? Log n whole power 9, right? I think everyone know this is bigger. Right? This is bigger. So finally, what is the answer now? After A, what is the next one? D. Which will goes to what is the answer? N into log n whole power 9. Next one, I think C. What is that one? N power 7 by 4. So answers are going to be A, D, C, E, B. A, D, C, E, B. A. Question number 11. What is the answer? A. A, D, C, E, B. This is a very small problem. Everyone can handle it. So answer for the 11 is going to be A. Let's see the problem number 12. Two alternative packages A and B are available for processing a database having 10 power k records. See this one. To process 10 power k records, two packages is having A package, B package. Two packages are there. To process 10 power k records, he is having two packages A and B. Right? That is fine. Next one. First of all, 10 power k records is having two packages A and B. It's fine. Now, what about A? What about B? Means you have to say something about A and B. He mentioned also. Right? Something about A and something about B is mentioned. You see, his goal is this only. 10 power k records he want to process using A package and B package. First of all, something about A package, something about B package you have to mention. He is mentioned. See this one? He mentioned. To process n records, can you help A package took how much time? 0.0001 n square time. N records it took this much time. What about B package? 10n log n base 10 time. For n records you took this much time, right? But he took 10n log n base 10 time, right? For n record this is the story. Now what about this one? 10 power k records, right? What about this person? What about this person? Let me check. If at all n records he will take this much time, he will take this much time. 10 power k records, right? Just nothing there. In the place of n keep 10 power k 0.0001 in the place of, right, n just keep 10 power k, right, whole square. N means n square, 10 power k means 10 power k whole square. What is there in that? Remaining constants are as it is. Next one, 10, that is also okay, right? N place 10 power k, that is fine. This will goes to log of, right? What is the answer? N means 10 power k base 10, right? Which will goes to what is the answer? 0.0001, right? Then what is the answer? I think 10 power k, right? A power m whole power and A power mn, it will become 10 power 2k. Right? What about this one? I think this k will come here. It will goes to k into log 10 base 2 is 1. I think it will become 10 power k plus 1. Right? Fine. Until now it's fine. Now let me go further. See this one, 0.0001 into, I think 10 power 2k can be written as, what is the answer? 10 power k into 10 power k. 10 power k whole square, meaning is same. This can be written as k into, what is the answer? 10 power k into 10. Right? I think 10 power k cancel. What is the remaining here? What about here? K into 10. Right? Fine. I think everything is okay. Now the next question is going to be, can you help me now? This is something about package A story, this is something about package B, but if you observe clearly, what is the last line? What is the smallest value of k for which package B will be preferred over package A? Now he is saying that to process 10 power k records, right, comparing A package and B package, he want to prefer B package. Package means what? It is something like algorithm, right? To process 10 power k records, comparing A package and B package means comparing A algorithm and B algorithm. They want to prefer B algorithm. Means you can prefer B algorithm if and only if, right? If B algorithm is having less time, he is having this much time, he is having this much time, right? So you want to prefer B package, means A should take more time. Can you help me one small line now? He is saying that what is the smallest value of K for which package B will be preferred over A, right? What K value I have to substitute? Minimum K value. You cannot substitute whatever way you want. For what K value, comparing A package and B package I can prefer minimum K value, right? So let's substitute. I think this side you want to make bigger. For which K value? Can you help me one small line now, right? If at all K value 1, isn't that K value 1, then what the answer? It is a 10, but this is going to be what the answer? I think very less value. Now can you help me once? It is a 10 already there. It is a 0 point, I think of 000 followed by 1. I think if at all, if you continue this one, if you continue almost like K value 4, right? K value 4 means I think 10 power 4. Then if you multiply 10 power 4, it will become 1 point something, right? But it is already 10 is there. 10 into 4, it will become 40, it is 1 point something. So what I want to say, 4 also not okay. If I keep 5, multiply by 10 power 5, what is the answer? I think 1 0 will be added here. It is a 10 point something, it is going to be, right? I think 50. Then also what is the answer? This side is not bigger, this side is bigger. So if the K value 6, then what is the answer now? Multiply this entire thing by 10 power 6, it will become, what is the answer? I think it will become, 2 more zeros will be added, it will become 100. If the K value 6, this will become 100, then what is the answer? It will become 60. So then I think K will be bigger. Smallest K value, I think K value 6 will be the story. K value 5, right only bigger. K value 4, right only bigger, but I want to make left bigger so that I can prefer B, right? What is the answer? K value 6 if you keep, minimum value. 7 also will work. That is the reason he is asking minimum K value so that package B will be preferred over A. I think minimum K value 6 will be the answer. So for this problem, answer is going to be C. Right? What is the problem number? 12. 12, right? Answer is going to be C. 6 will be the answer. What is the problem number 13? 12, okay. What is the problem number 13? What is the problem number 13? Very simple. Wn, An denotes the respectively worst case and average case time of the algorithm. Then which one of the following is always true? What is the Wn? Worst case. What is the An? What is the An? Average case. Then which one of the following is always true? Always true on the size of the input n. Now can you help me one small line now? Wn is worst case, An is average case. What is the relation between these two? Right? Always true. Can you help me now? Average case is omega of worst case. Indirectly saying that average case may be bigger than, right, worst case. There is no meaning in that. B, average case is theta of worst case. Theta means what? Equal. Both are always equal. No. If at all both are always equal, then why two names, worst case and average case? If average case is bigger than worst case, right, then what is the meaning of worst case? A cannot be, B cannot be. What is the option C? Right? A of n is big O of W of n. What is the meaning? Comparing average case and worst case may be bigger or equal. Big O means what? Greater or equal. Worst case may be bigger or equal. Sometimes may be equal also. Right? Option C, right. What is the option D? Average case is small o of W of n. What is the meaning? Worst case is always bigger than average case. Need not be always. Sometimes equal also. Always equal not. Always greater also not. Greater than or equal. Answer is going to be what is the answer? Option C. Question number 13, answer is C. Go to the question number 14. This also we done in the right classroom. Right? Question number 14, right? F of n is n. G of n is n power 1 plus sin n, where n is a positive number. Then which one of the following statement is true? F of n is n. G of n is n power 1 plus sin n. Then what is the relation between these two? Right? Let me check here. Let me check. It is n power 1. It is n power 1 plus sin n. Let's see here. 1 is n, 1 is n power 1 plus sin n. I will try. Roughly see this one. Roughly. Is there any game or not? Let's check here. It is a 0. It is a 0. Right? Now see this one. It is a 0 degrees. It is a 90 degrees. It is a 180 degrees. It is a 270. at the 360. Because of these are trigonometric functions, right? 360 degrees are more than enough. In these two people, who is bigger, who is smaller, we have to see. This one already we covered in the classroom also, right? In the notes already there. Let me give rough diagram. Can you help me now? Right? So 0, that's okay. Can you help me now? What about 90? Right? What about 90? What is the answer? What about the sign behavior? Sin 0 is 0, sin 90 is 1. Right? It is the sign behavior. If you want sign behavior also I am writing. Right? Sin 0, 0. Sin 90, 1. Right? So sin 180, 0. Sin 270, minus 1. Sin 360, 0. This is the sign behavior. Sign and behavior is like that. At the 0, at the 90, at the 180, at the 270, at the 360, at the 90. This is the sign behavior everyone now. Let's check here. Can you help me now? What is the Fn? N. What is the Gn? N power 1 plus sin n. Let's start. 0, it's okay. Can you help me now? 90 onward start. Can you help me now? N value 90. F of n function. What is the answer? Right? So it is 90 means it will go to 90. Right? Let's check here. So let me try here also. 90, 180, 270, 360. Some behavior. Let's check here. So 0 is 0, it's okay. Can you help me? What is the 90? F of n behavior? It will go to 90. Right? It will go to 90. Yeah, it went. 0 is 0 only, 90 is it went to 90. That's okay. F of n I am drawing. See from this yellow color whatever I am doing, right? That is isn't that F of n behavior. Can you help me now? 90 is 90. Can you say what about 180? It will goes to 180. I think this one. It will go to 180. This is 180. Next one 270, it will go to 270. Right? Next one 360, it will go to 360. It is going like that. That is the F of n behavior. Let's go to the G of n. Let's go to the G of n. Can you help me now? 0 is okay, right? 0 power anything is going to be 0, it's okay. Let's go to the 90 onwards. Can you help me one small line? What is the sin 90? Sin 90, what is the answer? Sin 90 is 1. Sin 0 is 0, sin 90 is 1. 1 plus 1, 2. Right? I think 90 square. At the 90, right? At the 90, what is the behavior? 90 square. So I think at the 90, it will grow like anything, right? 90 degrees, it will grow like anything. 90 square, what is the answer? It is a very big value. Forget about this area. 90 degrees onwards, we are concentrating. At this place, it is very big. 90 square. So at the 90, I want to say indirectly, directly. At the 90, comparing F and G, G bigger. That's okay. Can you help me now? What about sin 180? Sin 180, what is the answer? 0. So if sin 180 is 0, right, 180 whole power 1, 180, right, it will become 180. So 180 place, it will become, what is the answer? 180 place, it will become equal. 90 place, it will become 90 square, means very big value, right? 180 place, it will become 180. It becomes, both are equal. A rough diagram, see this one, rough diagram. Next one, can you help me now? What about 270? So F of n is 270, right? What about the G of n? Let's check here. What is the sin 270? Minus 1. 1 minus 1. What is the answer? 1 minus 1, which will goes to 0. N power 0, 1. What is the answer? I think F of n is 270, but this became 1. 1 may be somewhere here. This one. So can you help me now? At the 90, who is bigger? At the 90, who is bigger? G of n bigger. At the 180, both are equal. At the 270, I think F of n is bigger. This is more than enough. This is more than enough. Let's check at least here. Let's check at least here. So can you help me one small line now? What about sin 360? 0. So I think 1 plus 0 is 1. I think 360 power 0, which will become 360. So I think 360 once again equal. I think this kind of behavior. So starting if you observe who is bigger, G bigger, afterwards both equal. At the 270, who is bigger? I think starting place G bigger, right? Afterwards both are equal, right? At the 270, who is bigger? I think Fn is bigger. 360 once again, both are equal. I think this behavior is keep on going, right? So for every 360 degrees if you observe, sometimes f bigger, sometimes g bigger, I think we cannot say anything. Answer for this problem is, right? So we cannot say f bigger, we cannot say g bigger. See this one, if you can say big O omega possible, then theta. We cannot say big O also, we cannot say omega also, then you cannot say theta, right? What is the answer? Neither one nor two. Answer is going to be D. For this problem, answer is going to be, for the question number 14, answer is going to be fourth option. Just I took the rough diagram, I done this. Some people want to do like this, that is also okay. Some people done like this. See this one? Some people done. It is the n. It is the n power 1 plus sin n. This can be written as n into n power sin n. Right? N cancel. N cancel. Then what is the answer? This will become one constant function. This will become n power sin n. Right? These two things, common things you cancel. Right? Fn is 1, means constant function. Is always same, but this one n power, right? N power, right? Sin n. Now can you help me now? Some people are asking, sir, it is a constant function, right? It is a function, but this function sometimes increasing, sometimes decreasing. Can you help me now? Right? Sometimes negative function, sometimes positive function. So can you help me one small line now? Sin value is keep on oscillating from +1 to -1. Whenever it is 1, right? Then it is bigger. Whenever it is a -1, then this is bigger. It is keep on changing. Sometimes it is bigger, sometimes it is smaller. So I can easily say that directly like this you can say. I may be written the trigonometric diagram and all, that is okay. If you get this one, well and good. If you don't get, that is also fine. Same thing. I am not done anything, substituting values. Right? See this one. At the 90, if you see, one person is 90 square. G of n is 90 square. At the 90, if you see, right, it is almost like 90 square, some big number. Right? But one person is 90 only. At the 180, if you see, both are 180. At the 270, if you see, one person is 270, one person became 1. At the 360, if you observe, major points I took. At the 360, if you observe, one person 360, another one also 360. If you see the behavior, sometimes G bigger, sometimes both equal, sometimes F bigger. This behavior is going on for every 360 degrees, so we cannot say anything. One more easiest way, mathematically without diagram, if you don't want to waste time, you can do like this also. Common things cancel. n1, it is n power sin n. So sin n is keep on changing from 1 to -1, right? So it is a -1, then this is bigger. If it is a +1, then this is bigger. So we cannot say anything. So answer is going to be neither 1 nor 2. Question number 14, D is the answer. D. Question number 14, D. So question number 14, already we done in the classroom. In the classroom, many examples we done. There I said more clearly, right? Here roughly I said. Question number 14, answer is D. We cannot comment anything. F bigger or G bigger, we cannot comment. Question number 14, small doubt also there, right? Roughly I said. I didn't say that much clearly, roughly I said. Because in the classroom I covered many problems. That is the reason. Question number 15, option A. If f of n is big O of g of n, then g of n is big O of f of n. That need not be true. Right? Everyone know big O notation, symmetric property, right? Need not be satisfied. Right? Simple answer. N is big O of n square. N square is big O of n is fail. So option A is fail. Everyone know that. What is the B? F of n plus big O of f of n. F of n plus big O of f of n is equal to theta of minimum of f of n comma f of n plus big O of f of n is theta of minimum of f of n comma g of n. I think from where g came, right, that's okay. So this option, I think something wrong with the option B, right, leave it. F of n plus big O of f of n is equal to theta of minimum of f of n comma g of n. From where g of n is came, we don't know. I think something wrong with the option B, right, leave that. Something wrong. It is not a problem with you and with me, some problem with the option B. Let's go to the option C. Maybe printing mistake, maybe in the place of printing somewhere, right, f by g something maybe happened. Leave it. Go to the option C. F of n plus small o of f of n f of n plus small o of f of n is equal to theta of f of n. F of n plus small o of f of n is equal to theta of f of n. Right, so what about this option, is it right or wrong? We are already covered this one when our class is going on, right? That time I already said to you, f of n plus small o of f of n is theta of f of n. Is it right or wrong? Everyone know. What is the meaning of this? Here f of n, it is okay, but here see this one, here see this one. Here actual thing not written. Here whoever is there, right, to that person actual thing is not given. Comparing that person, f of n is strictly bigger. Here whoever is there, comparing that person, this is strictly bigger, indication that the person who is there in this area is less than fn only. So the person who is there in this area, to that he written the upper bound, strictly upper bound he written, indication that actual person is less than fn. Now can you help me now? Fn plus less than fn, theta of fn is right. See this one here, actual person is, there is a one person here, instead of writing actual person, right, to him strict upper bound is written, indication that actual person is less than fn. Actual person is less than fn. We have to talk about actual person only. Here actual person, see this one, not upper bound, not lower bound, it is the actual person. He is not actual person. For actual person, right, strict upper bound is fn, indication that actual person is less than fn. Fn plus less than fn, theta of fn, there is no problem. So option C is right. Let's go to the option D. Option D, log n factorial. Yeah. So option D, log n factorial and log n factorial are polynomially bounded or not, we have to verify. You know this very well. When can I say function is polynomially bounded? Right, a function fn is polynomially bounded, right, log of fn is, right, log of fn is less than or equal to log n. Again I am repeating now, a function fn is polynomially bounded if and only if log of f of n, right, is less than or equal to log n. Log of f of n is less than or equal to log n, right, please be careful. Then I can say it is polynomially bounded, right. For the more clarity, let me check here, right, I will explain here. See this one, mostly you know, if you don't know, see once. Log n factorial is polynomially bounded or not, I want to verify. How to verify? Right, log n factorial is an expression, right. What is the closest upper bound? Log n whole power log n, it is the closest upper bound. Log n factorial, closest upper bound is log n power log n, right, apply log here, if you apply log n into log n, if you apply log here, log n into log n, can you help me now? After applying for any function, after applying log, right, if its value is more than log n, see more than log n, then it is not a polynomially bounded, right. After applying log for any function, if its value is more than log n, yes, it is a more than log n, so it is not polynomially bounded, it is not polynomially bounded. Some people are asking, sir, can you repeat once again? When can I say a function is polynomially bounded? When can I say a function is polynomially bounded? After applying log, if its value is more than log n, it is not polynomially bounded. Let's check here also. Is it polynomially bounded or not? Let me check. Log n factorial, right? Upper bound, let me write. It is the expression. Let me write the upper bound. Log n whole power log n. It is the closest upper bound, right. Let me apply log here. What is the answer? Log n into log of log n, which will goes to log n into, what is the answer? It will goes to what is the answer? I think triple log n, log n. So can you help me now? Comparing log n and this one, who is greater? Log n is bigger. So comparing this one and right, after applying log on this one, after applying log on the given function, if you observe, this value is, right, less than or equal to log n. Either log n is bigger or, right, equal to log n, right, less also okay. See this one, I think comparing the left one and right one, left one is bigger, means log n bigger, means it is the less than log n, it is the polynomially bounded. For any function after applying log, if its value is less than log n or less than or equal to log n, then I can say polynomially bounded. So I think in the option D, log n factorial is not polynomially bounded. Log n factorial is polynomially bounded. Right? If anyone having still doubt, let me clarify. If anyone having still doubt, let me clarify. See this one. See everyone this one, mostly everyone know. Only for namesake I am writing. See this one. F of n is polynomially bounded. Polynomially bounded. F of n is polynomially bounded. If and only if. If and only if. Then what is the answer? Right? This is the answer. So everyone is carefully listen. Log n is greater than, right? Log n is greater than log of f of n. Right? If it is greater than or equal to also okay. F of n is polynomially bounded if and only if log n is greater than or equal to log of fn. Another way of saying same line. What is the answer? Log of fn is less than or equal to log n. Right? Then I can say polynomially bounded. Right? So I hope everyone is fine. This one everyone, only for namesake I explain. F of n is polynomially bounded if and only if log n is greater than or equal to log of fn. Another way of saying log fn is less than or equal to log n. What is the meaning? After applying log, its value is less than or equal to log n. Then I can say it is polynomially bounded. So log n factorial is not polynomially bounded. Log n factorial is polynomially bounded. Because of the expression, I took the closest upper bound. To that one I applied the log. After applying log, I got to know that log n is greater than this one. So it is polynomially bounded. Right? So after applying log, I got to know that it is more than log n. Right? It is not polynomially bounded. Now let's see about this problem. Problem number 15. Option A wrong, because big O notation symmetric property not possible. Option B, something wrong in that. In the problem itself, something wrong is there in the option B. Option C, f of n plus small o of f of n. Try to remember, here actual person there, here actual person not there. For actual person is a strict upper bound, means actual person is less than fn. Fn plus less than fn means fn is bigger. Fn is theta of fn, no problem. Option D, both are polynomially bounded. No, first one is not polynomially bounded, second one is polynomially bounded. So finally option D also wrong. Right? C is right, A is wrong. So finally for the question number 15, right, C will be the true statement, remaining is going to be false statements. Forget about the true and false. If anything you got newly, please learn it. If you think that something new you got, well and good. Try to remember, here actual person there, here actual person not there, right? For actual person, f of n is strict upper bound. So actual person is less than fn. Fn plus less than fn, theta of fn, no problem. So for the question number 15, only C is the true statement, remaining is false statements. Let's go to the question number 16. Question number 16, if you see, consider the following functions from positive integers to real numbers. Some functions are given, right? What are those? Consider the following functions from positive integers to real numbers. One is 10, one function. One more function is root n. One more function is n. So can you help me at the question number 16? The question number 16. Right? One is 10, one is root n, another one is n, another one is log n. Another one is 100 by n. These are the, I think, how many functions? Let me check. 1, 2, 3, 4, 5. 5 functions are given. Now, the correct arrangements of the above functions in increasing order of asymptotic complexity. Increasing order, we have to write all of them. 5 functions are given, they are asking. Increasing order, right? Can you help me now? Among all, it is going to be very small problem. Let's check once. Among all the people, who is smaller? Among all the people, who is smaller? Who is smaller? What is the answer? Among all the people, if you observe, who is smaller? I think this person is smaller. 100 by n. It is the 1 by n. It is simply Constant. It is going to be constant by n. Can you help me now? What I have to multiply so that I will get the constant here? What is the answer? N I have to multiply. What is the meaning? Here directly constant I will get, but after multiplying by n, I will get the constant. Indication that, right? He is the n times smaller than this person. After multiplying by n, then I will get the constant. But here directly constant. Indication that he is n times smaller. So can you help me know what is the first smaller? 100 by n. Can you say next smaller? 10. Right? It is the first smaller. I am giving the numbers. It is the first smaller. It is the second smaller. Everyone know that. Next one. Can you help in afterwards? Root n log n. Everyone know root n and log n. What is the answer? Log n also will decrease value. Root n also will decrease value. But log will decrease a lot. I think next one is log n. Next one is root n. You know this very well. It is the 3. It is the 4. It is the 5. Right? After root n is over. Next one is n. This is the order. Right, this is the order. So can you help me know what is the order here? 100 by n first, next 10, next log n, next root n, next n. So what is the answer? For the question number 16, answer is going to be B. For the 16, answer is B. Answer is B. Let's go to the question number 17. Go to the question number 17 now. Question number 17, if you observe. Right, what is the answer? One program is given. They are asking, let R of n be the recurrence relation which computes the sum of values printed by f of n. Then R of n is, can you say what is the R of n? R of n is a recurrence relation, it's okay. But for what purpose? Let R of n be the recurrence relation which computes the sum of values printed. Not time complexity. Let R of n be the recurrence relation which computes the sum of values printed by fn. Then Rn is, right? What is the program name? Let me write now. Program name. F of n is the program name, that's okay. Function name is f of n, f function. If you see inside, if n is less than or equal to 0, then return, that is okay. Else, what is the first one? Printf n. What is the second one? F of n minus 2. What is the next one? Printf n. What is the next one? F of n minus 1. End of this. Now see the answer. F of n printed value is R of n. F of n printed value is R of n. Please be careful. F of n function, time complexity normally T of n. But here what he said? F of n printed value is R of n, assume. If f of n printed value is R of n, f of n minus 2 printed value, what is the answer? R of n minus 2. F of n minus 1 printed value, R of n minus 1. Recursion is recursion. F of n printed value is R of n. F of n minus 2 printed value is R of n minus 2. F of n minus 1 printed value is R of n minus 1. That is okay. But one thing, he is asking printed, right? I think it is printing n. It is also printing n. Then can you help me? What is the recurrence relation finally? Printing means printed only, calculate. Recursion is always same. Printed means printed. So suppose that R of n is not printing. R of n is adding. Here there is no adding, 0. Nothing is added. Here also there is no adding, 0. But printed things is asking. R of n is printed things. Here printed thing is n. Here printed thing is n. Recursion is recursion. If R of n is addition, here there is no addition. Here also there is no addition. Because of he is asking printing things only take care. So finally what is the answer? R of n is equal to, what is the answer? R of n minus 1 plus R of n minus 2, right? Plus 2n. R of n minus 1, R of n minus 2 plus 2n, right? So can you help me now for the question number 17? What is the answer? R of n minus 1 plus R of n minus 2 plus 2n. C is the answer. For the question number, right? What is the number? Question number 17. Question number 17, answer is going to be C. Now suppose if the question is like this one, R of n is, right? R of n is number of additions. Then what is the answer? F of n number of additions are R of n. F of n minus 2 number of additions are Rn minus 2. F of n minus 1 number of additions are Rn minus 1. Because of here no addition 0. Finally Rn minus 1 plus Rn minus 2 plus 0. Means 0 means nothing there. Then answer is going to be at that time option A. If additions, answer is option A. Can you help me now? If the time complexity, what is the answer? These two are same, time complexity, because of here no loop constant. Here no loop constant. Then what is the answer? Rn minus 1 plus Rn minus 2 plus some constant C there. That is for time. This is for printing, this is the answer. For additions, it is not there. For a time complexity, here C there. Right? Anyhow, for the question number 17, answer is going to be C. Right, now go to the next one now. Question number 18. Question number 18. Question number 18, if you observe, one recursive program is given, they are asking what is the space complexity. Recursive program is given once, right? They are asking space complexity. Let me explain. Question number 18. Let me ask now. What is the function name? Right, some f. F or FOO, foo, whatever it is. Right? Question number 18, function name is f. If you want, I will write FOO of n. Inside if you observe, what is the answer? If n is equal to 0, then return 1.0. Else sum is equal to 0. Next one, for I is equal to 0, I less than n, I plus plus, sum plus is equal to foo of I. Afterwards, return sum. Afterwards, return sum. Right, this is the function foo of n. If n is equal to 0, return 1.0, else sum is equal to 0. For I is equal to 0, I less than n, I plus plus, sum plus is equal to foo of I, return sum, something like that. Right, to this program, what is the space? It is a recursive program, everyone know. Recursive program space is based on, right, number of levels in the recursive tree. I will try. Number of levels in the recursive tree. I will try. Many people know. Let me write this. Many people know answer for this one. To this recursive program, what is the space? Right. From this problem, I want to say one thing to you. Any recursive program is given. Carefully listen. From this problem, you have to understand this one. Right. From in gate examination or any examination. Space complexity question is given. They will give program. Please be careful. Without giving program, they don't ask you space. What is the reason? Different ways of writing the program. Depending upon how you write the program, space will be keep on changing. They cannot ask for a particular problem how much space you will take. Because depending upon how you write, space is keep on changing. Some will write recursive program, some will write non-recursive program. Right? Please be careful. Right? Any space complexity question is given. I am really saying to you, they will give program like this. So this program is given, they are asking space. And one more thing, non-recursive program space they may not ask. The reason is, non-recursive program there is no, right? There is no hidden space. Non-recursive program, everything is available in the program itself. But recursive program, some hidden space is there in the form of stack. Right? We will see now. We will see. Non-recursive program, right? There is no hidden space. But recursive program, there is a hidden space in the form of stack. So normally they will ask recursive programs only. Non-recursive program, hidden space not there. Recursive program, hidden space there in the form of stack. Normally space complexity questions are, right, recursive programs only. And one more, they will give program, they will ask the space. So program is given, they are asking space. And one more, because of space they are asking, right, some hidden space is there because of the recursion. How to calculate, you know very well. Draw the recursive tree by taking some example, you will get the clarity. Let me try this. See everyone now. See everyone. Foo of, in the place of foo I am writing f. Carefully listen, right? So f of 5 is equal to f of 5. What is the answer? Termination fail. Then for loop is going on. What is the answer? For loop is going on. I value 0, f0, I value 1, f1 and so on until I value 4, because I value 5 means 5 less than 5 is fail. Can you help me now? F of 5 internally calling for loop. What is the answer? Loop is going on 0, 2 less than 5 means 4. What is the answer? I value 0, f0 is called. Next one, I value 1, f1 is called. I value 2, f2 is called. Because see this one. right? So listen everyone now, foo is calling foo, that is okay, but in the loop it is calling, so many times it will call. Whenever foo is calling inside, many foos will come because of it is a for loop. Inside the loop there is a recursive call, means many recursive calls are there. So f of 5 internally calling, f0, f1, f2, next one f3 also, next one f4 also, next one f5 not there because 5 less than 5 is fail. Similarly, I think because of the recursion, whatever happened here, right, further also same story. But when you say stack space, right, maximum number of levels, see this one, at the termination stop, right? So because of when you say stack space, maximum number of levels, I think let me take the maximum. So what is the answer? It is the same. What is the answer? F4 internally calling, F0, F1, F2, right, F3. Next one, F3 is internally calling, F0, F1, F2. Right, F2 internally calling, what is the answer? F0, F1. Next one, F1 internally calling, F0. So like that. So see this one, I expanded the rightmost path. The reason is it is giving maximum levels. It is immediately stopped. It will go little bit far away, right? It will go little bit far away. It will go little bit. Among all of them, it is the largest one. So what is the answer? 5 is given. How many levels tree? 5, 4, 3, 2, 1, 0. 5 is given. 5 plus 1 levels there. 5 is given, 5 plus 1 levels there, n is there, n plus 1, n plus 1 level tree will come. So stack space is n plus 1, means n. The space complexity of the above function is, what is the answer? N. For the question number 18, answer is going to be B. Let me write here. Question number 18, answer is going to be B. Because they are asking stack space. You please remember, any program is given, they are asking space means, normally it is a recursive program. Non-recursive program, everything is visible. Recursive program only, right, something is hidden. What is that? Stack. What is the hidden thing? This one. This is the hidden thing. So space means normally recursive program. And one more, space means they will give program. Depending upon how you write the program, space is keep on changing. Next one, recursive program space is nothing but number of levels in the recursive tree. How many level? N plus 1. 5 means 6 levels. N means n plus 1 levels. And one more, if you observe clearly this problem, what is the answer? Right, foo of 5 internally calling 5 level tree approximately, but one thing, 5 level tree, that is okay, 5 level, 5 array tree, see this one, 5 level, 5 array tree. Some people are asking, sir, in the next level 5 may not be there. What is the meaning of 5 level, 5 array tree? Maximum 5 children are there. It is something like, right, if I call foo of n level, n array tree it will generate. N level, n array tree it will generate, right? Please be careful. N level, n array tree it will create. And some people are asking one more small line also. Sir, can you help me now? What is the one function cost? One function cost is going to be, right? After getting all, you have to add all of them n time. Right? After getting all, these all the things you will use it. So n time. Here also one function cost, all the things he will add, right, n time. So like that it is happening. One function cost because all the children he will use. Because of the n array tree, children's using will take n children are there, adding all will take, right, n time. Not adding 2 people, not adding 3 people, adding n people. If you add all these, sum is equal to sum plus f of this. So for the sum, you have to add all these people, which will goes to n time. Here also same, all the things you have to add. Here also all the things you have to add. So something like that. One function cost is n. One function cost is n. But anyhow, he is not asking time complexity, he is asking only space. Recursive program space, stack size. What is the answer? N plus 1 level tree. So n plus 1 level stack required. So stack space is n. For the question number 18, answer is B. And one more, what is the one function cost? One function cost is what is the answer? N. Because all these n people you have to add. Can you say what about this one? I think n children are there, everyone is n. I think n into n. First level cost is n, second level cost is n into n because n children are there, everyone is approximately n time, n into n. Next one, right, again one more n is there. So n, I think in next level n square cost, next level n cube cost and so on, n level, n power n. If you solve this one approximately n power n time you will get. If you add, this is the time. First level cost n, second level cost n square. First level one function call only, but right, that one function cost is n. Second level n function call, every function call will take n time, n square time. If you add all of them, what is the answer? Approximately n power n time. What is the time complexity? To this program, time complexity n power n, stack space is n plus 1, which is nothing but n. It is the time. It is the stack space. Right? Fine. Right. That is okay. For can you help me now? For the question number 18, what is the answer? B. So they are asking only stack space. How much? N. Can you help me? If that question is a time complexity, what is the answer? N power n. Because first level cost, right? First level one function call cost is n time. Some people are asking why first level cost is n. After getting all these all people you have to add, then you will get this. So I think some work is there. Some work is all these people adding will take order of n time. If 2 people adding, constant. 3 people adding, constant. I think n people you have to add, which will goes to n time. Second level, if you see n people, everyone is approximately n time, n square. Like that n levels are there, right? N power n. Like that n power n, right? Something like that. That is the time. But he is asking stack space only, answer is n plus 1. That is okay. Now come to the next one. Question number 18, what is the answer? B. Go to the question number 19. Question number 19. See this one? Question number 19. What he is saying? Suppose we modify the above function foo and store the values of foo of I, where I range from 0 to less than n, as and when they are computed. With this modification, the time complexity of function foo is significantly reduced. The space complexity of the modified function would be. What he is saying is, right, in this particular one, whenever you are right expanding, if you want, you can verify, right, lot of repetition is there. See, one path only I expanded, still lot of repetition, but one thing, here also you have to expand, here also you have to expand, here also you have to expand, next one, here also you have to expand, right, here also you have to expand, like that. So, when you are expanding, if you want, you can check, when you are expanding, so many functions are repeating. He is asking, right, as soon as you, whenever you are computing this particular one, right, if any function is repeating, if any function is you computed, as soon as you compute, store it so that if same thing is repeating, you can something like indirectly, directly. Question number 19 is saying that if you use dynamic programming, what is the meaning of dynamic programming? As soon as you compute, you store, so that if anything is coming back again, you can reuse it. So indirectly, directly, using dynamic programming to this problem, what will be the space? Using dynamic programming, you know very well, space may be little bit increased, but time will be decreased. Dynamic program will compute only distinct function call. Right? Dynamic program will compute only distinct function call. Normal program will compute all. If you compute all, how much time? N power n. If you compute all n power n time, right? So he is saying that this program space complexity how much? If you use dynamic programming will compute only distinct function call. Can you help me one small one? Using dynamic programming, what is the answer? Let me check. Using dynamic programming, what is the answer? I will check. Right? Can you help me? Because of you are using dynamic programming, 2 things will be there. 2 things. What are those? Stack also and table also. Because of dynamic programming, table required. Can you help me now? Using dynamic programming, what is the table? What is the table? How many distinct function calls are there? That much table required. Can you say how many distinct function calls? If 5 is given, f of 5 is given, including himself, right? 5, 4, 3, 2, 1, 0. I think 5 is given, 5 plus 1, 6 function call. N is given, n plus 1 distinct function call. So table size is, right, n plus 1 distinct function calls, which will goes to table size is n. Table size is n. Can you help me know what is the stack size? Everyone, in the case of dynamic programming, what will happen? As soon as you compute, right, you will store, right, you can reuse it. Let's check here. F of 5 will call, right, f of 0. F of 5 will call f of 0, right? F of 0 don't call anyone, right? Next one. When you complete this one, then you will go here. First f of 5 will call, it will push in the stack. Next one, f of 0 is called, it will push in the stack. Because of it is not depending upon anyone, you will complete. Until now stack size how much? 2. Right? After this is over, then you will go here. F of 1 will call, it is not available. F of 1 is not available. You will call the f of 0 is available. You don't call further. So I think you will reuse it and you will complete. So what, can you help me one small enough? You don't go further because he is available. It is over means you will come. Means f of 0 available, you don't do that. So I think here 2 levels. Afterwards pop, you will come here. So you will push here again 2 level. Because of it is available, you will use it. So again it is also pop. Now after completion of this one, so can you help me until now what is the stack size? Here 1, here 2, it is a popped means 1, again 2, right? Next one, I think because of it is available, you don't call further, it is a 2 only, now it is pop, it became 1, next one, it is a 2, afterwards I think it will call F1 already available, you don't call further, F0 it is already available, so 2 becomes, I think this is also completed, then you will go here. Right, f of 3 not available, further you will call 0, 1, 2 all are available. Next one, f4 will call, right, to complete f4 these are required, I think all are available. So I think whenever dynamic programming is going on, you know dynamic programming behavior, what is the answer? If it is already there, you don't call, right? Using dynamic programming, if you observe for this one, right, stack size what will happen, you don't call, see, you tried first, you will complete the left available, if left, see this one, left normally not available, left will take normally more space, but left height is very less here, in this diagram, left height is very less, because of left height is very less, right, dynamic programming stack will take very less, I think only 2 units of stack, right, so which will goes to constant space. Normally left will be more, everyone know dynamic programming starting slow. What is the reason? Left height will be more, then starting will be slow, but unfortunately left height is very less. That is the reason, stack space is very less. But in the case of without dynamic programming, left more height, right more height, I don't bother. Without dynamic programming, stack space, what is the answer? Number of levels. With dynamic programming, what happened is, left height normally we will consider, because right will be all are available. Left only not available, but here left height is very less. Because of left height is very less, right? When you are going further to right, all are available. I also thought that using dynamic programming, right? So stack space is n, I thought, right? But after observing few times, I got to know that using dynamic programming, stack space is going to be first one push, this also push. Right, afterwards it will pop, because of it is not depending upon anyone, it is over. Now stack space becomes 1, now again push 2, afterwards f0 is available, you don't call further, now f1 is over, now again stack space becomes 1, right, now again push 2, afterwards I think 0 available, 1 available, you don't call, now what is the answer? 2 also pop, now stack space becomes again 1, now 2, afterwards these are available, right, again pop, stack space becomes again 1, now again 2, afterwards, right, here these all are available, 2 only, maximum 2 units, right. Normally with dynamic programming, without dynamic programming, right, both the stack space will be same, but this problem is little bit different. Stack space here only 2 units, because of left height is very less, so that is the reason this particular thing is happening. Anyhow, can you help me now? Using dynamic programming, what is the total space? Stack space plus table. Table is depending upon distinct function calls, n plus 1 means n. Stack space is going to be, right, I think constant. Normally with dynamic programming, without dynamic programming, stack space should be same. But here in this problem something special, please you recheck again. 2 units of stack is enough. Right, table is going to be n overall, right, using dynamic programming also n space. Everyone know this one, using dynamic programming, normally space little bit will increase, right, but time will decrease a lot, but by God grace, whatever it may be the reason to this program, right, with dynamic programming, without dynamic programming also same space. But what is the time here? Can you help me now? With dynamic programming, what is the time? Let me check. With dynamic programming, this is the space. With the dynamic programming space, with the dynamic programming time, actually they are not asking, right, let me do here, with the dynamic programming time is completely based on how many distinct function calls, n plus 1 distinct function calls, right, next one, n plus 1 into every function call time complexity, what is the answer? Order of n, because out of n people finding the addition of all of them, n time, finally what is the answer? N square. Using dynamic programming, time complexity is n square, previously time complexity n power n. Using dynamic programming, time complexity becomes n square. See, n power n becomes n square only. Time decreased a lot. But space, if you observe, previously space is, right, only stack space. Now table also came. Because of dynamic programming, right? If something is available, you don't do it again. With that condition, stack space becomes only 2 units, but table size is n, overall is n. Can you help me now? For the question number 19, what is the answer? Let's check question number 19. Using dynamic programming, what will be the space? What is the answer? B. This is also B, n. Actually, n plus constant, n is the answer. Question number 19, answer is B. Question number 18, answer is B. If the question number 18, what will be the time? Time is approximately, upper bound is n power n. Without dynamic programming. With dynamic programming, what is the time? N square. But anyhow, time is not our concentration here. Don't think little bit also about time. My concentration only space here. Without dynamic programming, space is n. With dynamic programming also, space is n. For the 18, 19, answer is B. Yeah, question number 20. 18, 19 over, next one, question number 20. See this also, right? There are two functions f1 and f2. Two functions are given, right? Question number 20 is asking what are the time complexities of both. Question number 21, f1 of 8 watt, f2 of 8 watt, right? Like that, there are two functions are given. f1 and f2 two functions, what will be the time complexity? Can you go inside the f1 and check? Can you help me know? Is f1 is a recursive program or not? I am talking about question number 20, question number 21. Right? So go to the f1 function. If you go inside the f1 function, I think it is a recursive program. Recursive program, how to find out time complexity? Write the recurrence relation. See this one? f1 function I am writing. f1 of n time complexity Tn is equal to f1 of n time complexity Tn is equal to, right? Forget about small thing, termination condition. Think about major one. What is the answer? Tn is equal to, right? So f1 of n minus 1. So Tn minus 1 plus f1 of n minus 2, Tn minus 2. Remaining, there is no loop, nothing, constant. If you solve this one using recursive tree method, I think you will get the n level tree, n by 2 level tree, maximum n level tree. So because of two function called GP series, you will get 2 power 0c, 2 power 1c and so on, 2 power nc, approximately 2 power n. So for the f1 of n, time complexity is going to be 2 power n. What is the f2? Let's see the f2. F2 story, let me check. If you go to the inside F2, is it recursion or non-recursion? F2 is a non-recursion. And one more, inside F2, is there any loop? Non-recursion, it's okay. Is there any loop? Yes. Loop is how many time? I think n time. Actually n minus 1 time. I think 2 to n minus 1 time. I think second function called n minus 1 time will repeat time complexity big O of n. So time complexity means loops only. Right? Recursion is recursion, that is okay. Plus any loop is there. No loop, see. Here, only one loop is there, n minus 1. So I think for the f1 time complexity 2 power n, f2 time complexity n. So what is the answer? 2 power n and n. So for the question number 20, answer is going to be B. Question number 20, answer is B. One is a recursive program, write recurrence relation and solve. Why is C? Right? After function calls are over, no loop. Question number, right, I think if you see the f2 function, it is a non-recursion, right? Non-recursion means loops only one loop which is repeating n minus 1 time complexity n. So this is the question number 20 story. Right, go to the question number 21. Go to the question number 21. Question number 21 they are asking f1 of 8 how much, f2 of 8 how much. Let me check here. f1 of 8 how much. f1 of 8 value is asking values. What is the f1 of 8 value? Afterwards I will find out f2 of 8 value also. f2 of 8 also I will find out. Let me find out f1 of 8 value. Can you help me now? It is a recursive program. Recursive program value if you want to find out, I think you can do like this. Let's check here. Let's check. Can you help me now? What is the f1 of 0? f1 of 8 is my goal, it's okay. What is the f1 of 0 value? What is the answer? f1 of 0 is 0. What is the f2 of, what is the f1 of 1 value? f1 of 1 is 1. So I think termination, see the termination n0, then return n is 1, then return n. So 0 means return 0, 1 means return 1. Right, see this one. 0 means return 0, 1 means return 1. That is okay. Can you help me now? What is the f1 of 2? We are talking about f1 only. What is the f1 of 2? I think you have to go to the else part. If you go to the else part, what is the answer? f2, listen everyone now. f1 of 2 is equal to, if you go to the else part, 2 times of 2 times of, see, f1 of 2 is equal to 2 times of, right, f1 of 1 plus 3 times of f1 of 0. So which will goes to, what is the answer? I think 1 means 1, 0 means 0. So what is the answer now? It is the 2, it is 0, it is the 3. Fine, overall 2. That is the f1 of 2. I think from this one you can get the remaining things easily. Let's check here. What is the f1 of 3? What is the answer? 2 times of f1 of 2. 3 times of f1 of 1. What is the f1 of 1? We are already done. 1. What is the f1 of 2? f1 of 2, that is 2. Totally 4 plus 3, 7. Same way. Let's check here. Almost fine. Can you say f1 of 4? 2 times of f1 of 3 plus 3 times of f1 of 2. What is the f1 of 2? We done already. 2. What is the f1 of 3? 7. I think 2 7s 14, 3 2 6. 14 plus 6. What is the answer? 20. Right? Fine. Can you help me? What is the next one? 5. 2 times of 4. 3 times of 3. What is the 3 value? We done 7. What is the 4 value? 20. I think 40 plus 3 7s 21. What is the answer? 61. 2 into 20 40, 3 into 7 21. I think 40 plus 21 61. I think it is almost close. Can you help me now? What is the f of 6? What is the answer? 2 times of 5 61 plus 3 times of 4 20. It is going to be 60. It is going to be 122. 2 into 6 120, 2 into 60 120, 122 this one plus 60. 122 plus 60. 182. Same way. I think nothing there, you have to keep on expand like this. Can you say what is the f of 7? 2 times of 182 plus 3 times of 61. Right? I think last one is f8. 2 times of this value plus 3 times of previous value. Previous value is 182. What is this value? Let's check. 2 into 182 plus 3 into 61. 3 into 61, what is the answer? 3 6 18 3. 183. This one. This one. 2 2s 4. 2 8 16. 2 1s 2 plus 1 3. 8 6 14. 5 47. Right? So this one, add all of them. If you add all of them, how much will come? Right? It may be approximately 1640 will come. Please verify yourself. So like this only. No need to draw the big tree also. Indirectly, directly, same meaning. Indirectly, directly, same meaning. Question number 21 is they are asking f1 of 80 is how much? f1 of 80 is how much? Right? I think until 80 how to calculate. Whether you go for a tree or some other way, indirectly, directly this one. If you think that it is taking a lot of time, for all the people same time. Not only to you, for all the people same time. So 2 times of previous one, 3 times of before that. Right? Please you take care. I done a lot of calculation. If any way small mistake also there, please try to understand what is going on here. If you know the way, you can easily handle by yourself. Question number 21. Question number 21. f1 of 80 is how much? 1640 finally. Finally, what is the answer? 1640. What is the f2 of? Right, let's check this one. f2 of 8 also. Let's check here. f2 of 8. I think one loop is going on, which is going on from 2 to 8. Loop is going on from 2 to 8. Can you help me? What is the before that? Before that loop, let's check here f2. In the f2, I think one line is missing. See this one. What is the line given? x1 is equal to 1. That is okay. y1 is equal to 2. That is okay. z1 is equal to 3. This is the thing given. I think one more small line missing. Just take care this also. x0 is equal to y0 is equal to z0 is equal to 0. This line is missing. Please you take care. f2 of 8 also you have to calculate. x0, y0, z0 are all 3 is going to be 0. x1 is equal to 1, y1 is equal to 2, this is 2. z1 is equal to 3, right, like that. This is the given information. Now loop is going on. Let's start the loop. right? I is equal to 2 going on. Can you help me? I is equal to 2. What is the answer? Check. I is equal to 2. In the similar way, I is equal to 3 also. Similarly, I is equal to 4 also, and so on 8. Right? Verify yourself. So what is the answer? Right? If you continue this one, what will happen? Let's check here. So I is equal to 2. Inside, can you check? What is the answer? X2 is equal to what is the answer? X2 is equal to Y1 plus X2 is equal to Y1. What is the answer? 2 plus Z0. What is the answer? 0. So it is 2. Next one. What about next one? What about Y? Let's check the Y also. Y2 is equal to what is the answer? 2 into X2. What is the X2? Already we got. X2 is going to be 2. So this is going to be what is the answer? 2 into 2, which is going to be 4. Let's go to the next one. Z2 is equal to what is the answer? 3 times of that one. What is the answer? 3 into 2, which will goes to 6. So like that. First find out the X2, 2 times of this one, right? So first one is going to be 2 times of this one. Next one is going to be 3 times of this one, like that. Now similar way, let me find out. What about X3? See the formula same way, right? I think X3 is equal to Y2 and Z1. Can you help me? What is the Y2? What is the answer? 4. What is the Z1? What is the answer? Z1 is going to be 3. It is going to be 7. Now in the similar way, what about Y3? 2 times of this, 14. Can you say what about Z3? 3 times of that one. What is the answer? 21. Right? Same way. Can you help me? What about X4? What is the answer? I think Y3, how much? Y3, how much? 14 plus. Right? So Z2, what is the Z2? Right? Which will goes to 6. Which will goes to 20. Can you help me now? What about Y4? 2 times of this, 40. What about Z4? What are the 3 times of that? 60. It will continue like this. Let me check here. It will continue. Lastly, what is the answer? What is finally is asking? Return x of n. Finally, I want the x8. Right? So x8 you find out. You make it approximately. That is also 1640. Please check. X8 you find out. Right? Almost similar answer you will get. Whatever you got, see this one. F1 of 8, F2 of 8 is same. Please calculate. Same or not doesn't matter. Just see the way. That's it. So the purpose of saying question number 21 is going to be how to find out F2 of 8. Right? F2 of 8 to calculate. Right? This only given in the problem. This is little bit missing. I written this. Afterwards simply substitute. Right? Finally, I done this one many times. 1640 may come. Right? Please verify. For the question number 21, what is the answer? C. Question number 21. Let me write here. It is the question number 21. Question number 21, answer is C. Question number 20, answer is B. 20 is B, 21 is going to be C. Right? Fine. How to find out that one is a recursive program, one is non-recursive program. Recursive program time complexity 2 power n, non-recursive program time complexity n. And one more. Whatever first one is doing, whatever F1 is doing, F2 also doing same. One is recursion, another one is non-recursion. Depending upon how you return, time complexity may increase, may decrease, but value will be same. Question number 20, time complexity is if you see 2 power n and n, but question number 21, values will be both are same because both F1 and F2 will do same. One is recursion, another one is non-recursion. That is the 2021 story. Right? Go to the question number 22. Question number 22. So I think GCD of m comma n where n is greater than or equal to m. Right? That is the given one. Then they are asking to this GCD program, right? How many function calls, how many recursive calls are made? This is there in your notes also. GCD of m comma n will take how many recursive calls, right? You know very well. Can you help me now? Whenever GCD program is running, when the best case will come, given two numbers are multiples to each other. See the program also. Given two numbers are multiples to each other, immediately you can stop. When the best case will come is given two numbers are multiples to each other, at that time only one call. At that time only one call. If the given two numbers are two consecutive Fibonacci numbers, then number of recursive calls are going to be log of whichever is big number. Which is the big number? N. Log of n. GCD function, right? How many function calls? Right? Best case one function call, worst case log n function calls. Right? Best case one function call, worst case log n function call. Assume that because of the recursive program, GCD of m comma n, number of recursive calls are assume that Tn. GCD of m comma n, number of recursive calls are assume that Tn. Tn minimum value 1, Tn maximum value log n. Maximum value log n means what? Worst case log n. Best case 1. So to this problem, answer is this one. Where Tn is the number of function call. GCD of m comma n, number of function calls are Tn. Where Tn lies from, right? Minimum is 1, maximum is log n. If you want, you can write the notation also. Tn is equal to minimum is 1, right? Maximum is log n. Maximum means what? Upper bound. Right? Log n. Now, in the option whichever is available, you can select it. Which one? So, I think Tn having two choices, 1 also, log n also. Let's check the option A, right? So, left hand side is the Tn is there. Tn is theta of log n, no. Theta means what? Tn and log n both are equal, no. Tn having two choices, 1 also there, log n. Tn having don't have one choice, two choices. Tn may be 1, Tn may be log n. So can you help me now? Tn is having two choices, 1 also, log n also. Can I write? Tn as theta of log n? No. Big O of log n you can write. Omega of 1 you can write. Right? Because he is having 1 also. If at all 1 is there, 1 is omega of 1, true. If at all log n is there, log n is omega of 1, true. Right? Next one. Here 1 is there, 1 is big O of log n, true. If at all log n is there, log n is big O of log n, true. So it is the actual answer. But if you observe clearly, option A fail, option B, omega of n fail, option C fail, option D fail. So I think because of everywhere theta is given, it is fail. So, but one thing I want to ask you, actually this is the correct answer, but in the given options no one is matching. I think maybe is asking, right? Worst case maybe. Otherwise option A, right? Option A you can take by taking in the place of theta big O. Right? Option A you can take by keeping in the place of theta big O. Suppose to make this problem very simple, right? How many recursive calls are made by this function? Worst case, you can take worst case also. Worst case then going to be log n. Can you help me? Suppose if the question contains worst case, what is the answer? Tn don't have two choices. Because of he himself mentioned worst case, only one choice, then Tn becomes log n. If the question saying that, right, GCD of m comma n will take how many function calls in the worst case, then Tn is going to be GCD of m comma n, number of function call in the worst case. If that is the case, this is not there. GCD of m comma n, number of function calls in the worst case is Tn, then Tn having only one choice, log n, then answer is going to be log n is theta of log n will come. So it's because of he is not mentioned best case, worst case, everything I written. Actual answer is this. Because of it is not there in the problem, just change little bit. What is the answer? Just in the problem write worst case. Worst case number of function call. Then Tn having only one choice, log n. Then what is the answer? Tn is log n only. Log n is theta of log n. Then this is correct. For the question number 22, actual answer is this only. But no option is matching like that. So in the question just write somewhere worst case. In the question write somewhere worst case, then answer is this. When you written the worst case, Tn having only one choice, log n. So Tn is log n is theta of log n. For the question number 22, answer is going to be A with a small modification, worst case you keep. Suppose if the question is best case, then what is the answer? Same problem, best case. What is the answer? Tn is the GCD of m comma n, number of function called best case. Then Tn having only one choice, that is 1. Tn having 1. Now come to the option. What is the answer? Which option is right at that time? Tn is 1. 1 is theta of log n, fail. B. 1 is omega of n, fail. C. 1 is theta of log n, fail. D. Right? Theta of 1 is theta of root n, fail. Then everyone is fail. If at all, right? If at all Tn is going to be, right? What is the answer? Best case. Best case means no one is matching. Worst case means I think A is matching. Just keep the worst case, answer is this. If nothing is mentioned, answer is this. So, because of nothing is mentioned, I think worst case, this is the one. Just I think maybe is asking worst case, that is the answer. In the available one, best one you select. Right? Maybe is asking worst case, answer is A. Actually, to this problem, right, no one is there. No one is there in the option which is matching. Right? If you want the matching answer, just add the worst case, answer is this. Finally, question number 22. With the small modifications, worst case, answer is option A. Answer is option A. That is the question number 22. Right. Now go to the next one. Question number 23. Question number 23. So what is the answer? Question number 23. One recurrence relation is given. You have to solve it. You know very well. What is the answer? N power log 7 base 2, which will goes to n power 2.81. You know very well. This one we solved also. Log 7 base 2. I think B is the answer. Question number 23. Answer is B. Go to question number 24. Go to the question number 24. Question number 24. Two things are given. You have to match them. Let's match one by one. A, B, C. How many people are there? D. 4. This is the group 1. This is the group 2. What are the group 2 names? 1, 2, 3, 4. Two groups are there. List 1 and list 2. You have to map. I am mapping now. See this one. Very simple. I am mapping. Can you help me now? Can you help me now? A. T of n is equal to T of n minus 1 plus n. If we solve this recurrence relation, what is the answer? This is the first recurrence relation which we solved. What is the answer? It will become n square. It will become n square. So I think for the A, 2 is the answer. It is n square. So A2. Next, go to the B now. B is going to be Tn is equal to T n by 2 plus n. Because of decreasing GP series, it will become n, right? For this one, 1 is the answer. So, what is the answer? B1. That is also okay. Go to the C now. Go to the C. Tn is equal to, what is the answer? Tn by 2 plus n log n. Tn is equal to Tn by 2 plus n log n. Right? So we will see afterwards. You can solve also, right? If you want, you can solve using substitution method. You can solve. It may be decreasing GP series. It may be n log n. I don't know. But one thing, we will see that. We'll see that. Right? So if required, we will do that. Next one. What about D? Let me do first, which we know very well. D. What is the answer? Tn is equal to, what is the answer? T n minus 1 plus log n. I think if you see this one, if you see this series, what will happen is first log n, next log n minus 1, next log n minus 2, log n minus 3. It will become log 1, log 2, log 3 and so on log n. It will become log of n factorial, which will become log n log n. Log n factorial, which will become n log n. So D going to be n log n. Which option? D going to be n log n. I think D going to be 3, n log n. What is the D? 3. If you see the option A, 2 times 3 is given. C also 3, D also 3. Please solve it. Please solve it, other than nothing. If you want, you can go to the master theorem also. Let's check here master theorem, using master theorem. Can you help me? What is the f of n? F of n. What is the answer? N log n. What is n power log A base b? N power log A base b. What is the answer? Log 1 base 2. N 1 can be 2 power 0. Log 2 power 0 base 2. It will go to n power 0 1. So comparing these two people, who is bigger? I think n log n is bigger. N log n is bigger. Can you help me? N log n is bigger. It's okay. How many times? N times bigger. E is bigger by n times. E is bigger by n times. I think master theorem is possible. See this one. Bigger by n times. N is there. See this one. N log n time. In the n log n, n is there. Means polynomial time is there. So answer is going to be n log n for this one. Just compare both of them. I think this is smaller, this is bigger, it's okay. Can you help me? Is smaller by how many times? N log n time. In the n log n, n is there, means polynomial times is smaller. Polynomial times smaller or polynomial times bigger. Right? Master theorem is valid, you know very well. Then at that time answer is going to be, whoever is bigger is the answer, n log n. So for the C also, see this one. For the C also answer is going to be n log n. This also n log n. This also n log n. Right? C also. Because of that is there, I done. Otherwise I don't do. Question number 25. Let's check. Right, question number 25 is a very interesting one. Please listen. Please listen. This is something like first problem. Question number 25 is very important one. To say this question number 25 only, I am solving the workbook. Please be careful. Question number 25. See this one. One recurrence relation is given. See this one. T1 is equal to how much? 1. Tn is equal to, what is given? 2Tn minus 1 plus n if n is greater than or equal to 2. T1 is 1, Tn is equal to this one. If n is greater than or equal to 2, that's okay. Now he is asking, if you solve this recurrence relation, which will be the answer? If you solve this recurrence relation, which will be the answer? Right? This problem, it is very, very important one. Question number 25, what is the answer? If this recurrence relation is given, if you solve this one, what is the answer you will get? You know very well how will you solve? You have to go for substitution method, you can solve, right? If you go to the substitution method, you will get the AP-GP series. If you solve this one, it will take approximately 10 minutes or 15 minutes. You can solve this one using substitution method. It may take 10 minutes or 15 minutes. Best idea is for the question number 25, if you see the options, right? Options are given mathematically. If options are given mathematically, best idea, substitute values. Mathematically means what? Exact answers, right? So substitute the values, you will get the answer. One is going to be just to do substitution method, you will get the exact answer. Just one more idea, best idea is going to be, because of it anyhow mathematical things, right? Just to substitute the values. Instead of substitution method, right? Substitute the values, right? This will solve within 1 minute only. If you do substitution method, it will take 10 minutes or 15 minutes. If you do substituting values, it may take 1 minute or 2 minutes. Let me try now. T1 is equal to 1, okay. Right? Tn is this one. Can you help me? What is the T2? From this, T2 is equal to 2T1 plus n. n is what? 2. What is the T1? 1. It is 1, which will goes to 4. T1 is 1. 2 into 1 is 2 plus 2. So 4. Can you help me now? 2 is given 4. Which option check in the option? If n value 2 given, 4 should be the answer. So can you help me know which option? If you see the option A, right? 2 cube, 8 minus 2, 6 minus 2. What is the answer? I think 4. Option A is giving 4. What is the option B? 2 square 4. 4 minus 2, 2 only. No. Option C, right? 8 minus 4 minus 2. It will become 2. No. Option D, 2 square 4 plus 2, 6. I think option A only matching. That is the answer for this. For the question number 25, right? How to solve this recurrence relation? Using substitution method you can do. It will take 10 minutes or 15 because AP-GP series big story will come. But one thing, right? Because of options are given mathematically, why don't you substitute values? After substituting T2, immediately I got the answer. Suppose some people are asking, after substituting 2, you got 4. 2 options are matching. Unfortunately, what will you do? T3 also you do. You will get the clarity. For the question number 25, what is the answer? A. Just to substitute values, not substitution method. Both will give correct answer. One will take 10 minutes, one will take 1 minute. 25 answer is A. What is the 26? Question number 26. Question number 26, one program is given, they are asking the number of correct assertions are. And one more thing, one program is given. What is asking? If you see the S1, S2, S3, they are asking about time complexity only. Can you help me now? Recursive program time complexity, how to find out? Write the recurrence relation. Write the recurrence relation. BAR of n, time complexity Tn is equal to. BAR of n, time complexity Tn is equal to. So can you go inside? If you go inside, is there any loop? I think first loop is there, second loop is there, third loop. But one thing, second loop, third loop is inner loops. First loop is outside loop. Can you help me now? Tn is equal to, what is the answer? BAR of n by 2 is Tn by 2. That is happening 4 times. 4 times Tn by 2. BAR of n is Tn. BAR of n by 2 is Tn by 2. That is there inside the loop. 4 times this loop is going on. Plus. Can you say after that one? Right? First loop is over means function calls are completed. Second loop, third loop, which are inner loops, right? Some work is going on. Can you help me know? Second loop, third loop combined how much? I is equal to 1, j loop until I. I is equal to 2, j loop until I. I is equal to 3, j loop until I. So I think this area if you observe, what is the answer? This is the case. I is equal to 1, j loop is 1 time. I is equal to 2, j loop is 2 time. I is equal to 3, j loop is 3 time and so on at the end. Right, which will goes to sum of n natural number n square. This will become, right, overall story it will become, what is the answer? 4t n by 2 plus n square. Right, using master theorem, what is the answer? F of n is n square. right? N power log A base B, log 4 base 2. This is also n square. Can you help me now? If both are equal, then what is the answer? If both are equal, take one person, multiply by log n. You know this very well about master theorem. So the answer of this problem is going to be n square log n. The answer of this problem is going to be n square log n. Please be careful. Tn is n square log n. Tn value is n square log n. Please be careful. Now let's check here. Tn exact answer is this n square log n. Let's check one by one. Right? S1 statement. Try to remember Tn is n square log n. Let's check one by one. What is the option A? What is the S1? S1, let me check here. See this one. Br of n means Tn. Tn is theta of n square log n. True. What is the S2? Br of n. What does it mean? Tn. What is the Tn? This much. Right? Tn means n square log n. Right? Can you help me now? S2, if you see, n square log n is omega of n square log n square. Everyone, what is the meaning of omega? Which side is bigger? Left side, right side. Which is bigger? Left side is bigger. Omega means n square log n. Brn means n square log n is there. N square log n is omega of n square log n square. Log n square means how much it is? I think it will become 2 log n. Negligible. So I think option B, S2 also correct. What is the S3? N square log n is big O of n cube log n square. I think because of big O, right hand side bigger, true. I think S1, S2, S3, true. Can you help me now? Finally, I am asking you, what is the Tn you got? This. Tn is this. Try to remember, Tn is this. Now compare one by one. Br of n means Tn. Tn is this. Now let me check this one. Option S1. This is n square log n. Let me check here. N square log n is theta of n square log n. Is it right or not? Yes. S2. N square log n is omega of n square log n square. Because of this 2 will come here. I think same. Next one S3. N square log n is big O of n cube log n square. Log n square. I think big O. Big O means this side bigger. I think all are true. Actually, we think that S1 is true. S1 is, if at all, right, options are given. Right, 4 options. S1, S2, S3, which is correct. Then I will go for S1. But one thing, S2 also correct, S3 also correct. Suppose if they are asking how many true, all true. So finally, for the question number 26, what is the answer? The number of correct assertions are, what is the answer? All 3 are correct assertions. All 3 are correct assertions. For the question number 26, actual answer this. This is the answer. Tn is this. Question number 26, Tn is this. Now they are comparing. Tn means this one is theta of n square log n, true. Omega of n square log n square, that is also true. Right? Big O of n cube log n square, that is also true. The number of correct assertions are 3. Suppose one you have, if you want to select all are correct, closest one you can select. I think it is the tightest one, you can select it. But he is asking number of correct assertions are 3. So for the question number 26, answer is 3. D is the answer. D. 3 means what? D is the answer. Go to the question number 27. Go to the question number 27. Question number 27. It is the towers of Hanai. Until now I am not done. Right? It will come in the further class. Question number 27. Right? He is asking reconciliation for time complexity of towers of Hanai. Towers of Hanai time complexity Tn is equal to. Question number 27 belongs to towers of Hanai. Towers of Hanai of n time complexity Tn is equal to 2 recursive calls are there of n minus 1, Tn minus 1 plus some constant time. This is the actual one. So answer is going to be D. Afterwards you will see that. For the question number 27, towers of Hanai time complexity recurrence relation, inside 2 recursive calls are there of size n minus 1, Tn minus 1. Further no loop is also there, constant. So for the question number 27, time complexity is going to be, this is the reconciliation, option is going to be 4th option. 27, 4th option. What is the question number 28? Question number 28, please go through it. 28, I think one function is given, this one may be there in your notes also, one recursive program time complexity. What is the answer? Do something of n time complexity Tn is equal to, do something of square root of n, so t root of n plus no loop is there, constant, right? So do something of n Tn time, do something of root n, t root n. Further no loop is there, constant time. If you solve this one, right, if you solve this one, answer is going to be log n. You know this very well. For the question number 28, answer is going to be, what is the answer? Log n, D, fourth option. Go to question number 29. Question number 29. What is the question number 29? If you observe, what is the answer? See the interesting one. This also interesting one. These are the things, right? This is the place where people will get the ranks. I am saying to you, if you do blindly, you don't get the rank. Use little bit of common sense. Computer science gate examination purely based on common sense. You should need common sense also. Don't doing blindly, taking the problem, doing blindly, no. Use little bit of common sense. Can you help in question number 29? What is the answer? Let's check here. Let's check. T of n is equal to root 2 T n by 2 plus root n. Right? This is the reconciliation. And one more. T1 is equal to, what is the answer? 1. This is the reconciliation. If you solve this reconciliation, what will be the answer they are asking? Okay, I can solve using substitution method, everything fine. But if you see the option, right, mathematically or asymptotically, options are given mathematically or asymptotically. So what is the answer? Mathematically given, substitute the values, you will get the answer. Substitute. Can you help me now? T1, what is the answer? 1. What is the T2? Let me check T2. T2 is equal to, what is the answer? Root 2. Root 2, it will become T of 1 plus it is also root 2. Which will goes to root 2 plus root 2. Because the T1 is 1 only. Which will goes to 2 root 2. Right? Answer is going to be 2 root 2. Can you help me one small line now? N value 2, which will give 2 root 2. Please verify. N is 2 is given. Who will give 2 root 2? Please verify. Option A, what is the answer? Log 2. Right? Option A, if you see, log 2 base 2. What is the answer? 1. Which will become, right, 2 root 2. I think option A looking like answer. What is the option B? Root 2 log 2 base 2 is 1. Isn't that everywhere base 2? Assume, right? Root 2 log 2 base 2 is 1. No. Option C, root 2 log root 2. No. Option D, 2 log root 2. I think 1 by 2 it will come. So this is also, I think answer is going to be A. Substitute the values. If those people, listen, in gate examination, some point of time this question is came, those people who are using substitution method, they also give an answer, but they don't have brain, right? They don't have common sense. That may be the reason they done that one, but still they may not get the good gate rank. Please use common sense. I think by seeing options, I can say substitute the values. So for the question number 29, what is the answer? Option A. Please check. One line itself answer is coming. Suppose some people are asking, by substituting 2 options are matching. Try, right? N is equal to 4 also. Right? For the question number 29, answer is going to be option A. Right? Let's go to the question number 30. Yeah, question number 30. One reconciliation is given. You have to solve it. Question number 30, one reconciliation is given. You have to solve. Tn is equal to 2t n by 2 plus log n. Right? I think let's check master theorem is possible or not. See, this one, it is a nice one. Right? Let me give that clarity also. In the classroom also, I already mentioned. If you have little bit doubt also, you can see once. What is the Fn? Log n. What is the n power log a base b? Right? N. So, one is log n, another one is n. You see, you talk in whatever point, whatever way you want, you can talk. Let's talk here. Everything is okay. Let's talk here. Can you help me? Smaller or bigger? Smaller. Smaller, it's okay. How many times smaller? What I have to multiply so that I will get? How many times smaller? N by log n times is smaller. N by log n times is smaller. What is the meaning? I think n is there. Forget about n by log n is there, log n is there. Don't bother. N is there or not? Yes. Indication that is polynomial times smaller. N by log n times smaller, that is okay, but n is there. N is there. So, E is a polynomial times smaller. Another way of saying, is polynomial times bigger. What is the reason? Log n by n cancel. Is a polynomial times bigger, is a polynomial times smaller. If I divide this one by polynomial, right, then I am getting both as equal. So, is polynomial times smaller or is a polynomial times bigger? Indication that master theorem is possible. Then what is the answer? Whenever polynomial times smaller, polynomial times bigger, then what is the answer? Whoever is big is the answer. Answer for this problem is n. Polynomial keyword. Polynomial keyword doesn't mean that n only will come, n by log n also. N is there or not, that matters. N square also okay. N square by log n also okay. Log n by n square also okay. But one thing, only logs not there. If only logs there, third case, you know very well. Between those two, no difference at all. Only log difference, then also third case. Right? Next one, polynomial difference is there. Smaller or bigger, it's okay. Polynomial different, polynomial keyword is coming. Polynomial followed by log. Polynomial followed by log. Polynomial divided by log. Log divided by polynomial. So only logarithmic, then third case. No difference at all, third case. Polynomial is there, first case, second case. So polynomial times bigger, polynomial times smaller, master theorem, first case, second case, then whoever is bigger is the answer. So can you help in question number 30? What will be the answer? N. So option A. Using master theorem. Using master theorem. Yeah, go to the question number 31. 31, one recurrence relation is given. Question number 31. One recurrence relation is given. They are asking if we solve this one. Question number 31. Question number 31. One recursive program is given. They are asking what is the time complexity. What is the answer? What is the function name? A. So A of n time complexity Tn is equal to A of root n. What is the answer? T root n. Afterwards no loop, nothing, constant. Right? So next one. If you solve this one, what is the answer? Log n time. Question number 31. Answer is going to be log n. So C is the answer. Go to the question number 32. 31 over, go to the question number 32. One recurrence relation Tn is equal to 3Tn by 2, I think so, plus n. Options are given, asymptotically you have to solve. Right? Where T1 is equal to 1, that is also okay. Then if you solve this one, what is the answer? Maybe you can apply master theorem. Can you help in f of n? N power log a base b. What is the answer? N power log 3 base 2, which will goes to n power log 3 base 2, 1.5 maybe. So can you help in who is bigger? N power, right? 1.5 is bigger. How many times? Root n time. Root n is a polynomial. So whoever is bigger is the answer. Answer is going to be n power 1.5. Answer is going to be option B. Right? What is the question number? Question number 32. Answer is B. This is the reason for that. Go to the question number 33. Right, question number 33. Let's see the S1. What is the S1? If you see the S1, right, R range from 0 to log n minus 1, n r by 2 power r. So what is the answer? What is the first one? R range from 0 to log n minus 1. So first one, R value 0, total becomes 0. R value 1, what is the answer? R value 1, what is the answer? N by 2 power 1. Here 1 is there. R value 2, what is the answer? R value 3. Last, what is the last R value? Log n minus 1. Log n minus 1 into n by 2 power log n minus 1. So I think if you see in this one, n common. Remaining if you observe, what is the answer? So like this, n common. I think it is APGP series. It is the APGP series. Assume that this is, right, S1. This is S1, assume that. Can you help in APGP series? How to convert into GP? What is the answer? GP series, what is the GP? So 1 by 2 whole square and so on. In the GP series, R value 1 by 2. Multiply by 1 by 2. So if you multiply, what is the answer? This n is same. This n is same. If you multiply, what will happen? Right? Multiply this one by 1 by 2. It will become here. Here. So what is the answer? Here. So before that, whatever is there, what is the answer? If you multiply, what will happen? Log n minus 2 into one more log n minus 1 into log n. Here I think nothing there, 0. Here also nothing there, 0. Right? Solve it. If we solve this one, what is the answer? This will become s1 minus 1 by 2 s1. It will become, what is the answer? s1 by 2 is equal to, n is already there. Right? Now substitute. Right? Simplify now. It will become 1 into 1 by 2 whole power 1. This one. You are subtracting. What is the answer? 1 into 1 by 2 whole square. 1 into 1 by 2 whole cube. Can you say what is the last one? What is the last one? This one also you see here. What is log n minus 1? The log n minus 1 difference. 1 into 1 by 2 log n minus 1. What about remaining? Remaining, if you observe, what is the answer? Minus log n minus 1. 1 by 2 log n. Right? Like this. Next one. See this one, next one. S1 by 2 n into. Can help you now. This entire series, if you see, how many terms? Log n minus 1 terms. Right? This is going to be constant. Right? See, so it is a GP series where r value less than 1. Formula you know, a into 1 minus r power n. It will becomes constant. Minus log n minus 1 into 1 by 2 whole power log n. Right? This is going to be S1. Next one, can you help you know? It is S1 by 2. Just send the 2 this side. S1 is equal to 2n, it's okay. Right? This is everyone. 1 by 2 is, right, 0 point something. If you do log n time, right, it becomes almost like negligible, means 0. 0 into something becomes 0. Finally, what is the answer? 2n into constant. Finally, it will become n, order of n. You know very well how to solve it, right? No need to think that much. So S1, right? S1 reconciliation, S1 series, if you see, finally n will become. Some people are asking, sir, how can you neglect this, right? 1 by 2 is almost 0.5. If you do 0.5 whole square, 0.25, 0.25 whole square, 0.0625, decreasing, if you do function time, it will become almost 0. 0 into something becomes 0. So finally, n into constant, finally n is the answer. S1 is n. Right? Don't think that much. You know very well how to solve it. Because of I done many times, I done little bit fast. Question number 33, S1, n. Right? Let's see the S2 also. Question number 32, S1 is going to be n. What about S2? Let's check here. S2. What is the S2? If you see the behavior S2. Right? S2 may be this one. R value 1 onwards start. What is the answer? 1 into 2 power 1. 2 into 2 square. 3 into 2 cube. Lastly, what is the answer? Log n minus 1 into 2 power log n minus 1. It is once again AP GP series combination. So what is the answer? GP series R value 2. 2s2 you do. Which is going to be, what is the answer? 2s2 if you multiply by 2, it will become 1 into 2 square. 2 into 2 cube. Next one, it is going to be log n minus 2 into 2 power log n minus 1 plus log n minus 1 into 2 power log n. It is a 0. It is a 0. Subtract now. It will become S2 minus 2S2. What is the answer? Minus S2 is equal to. What is the answer? If we subtract here 1 into 2 power 1. 1 into 2 square. 1 into 2 cube. What is the last one? This one if you see. 1 into 2 power log n minus 1. This one minus log n minus 1, 2 power log n. This entire thing, right? 1 GP series. Let me write now. Minus S2 is equal to What the answer? This one. Sum of n minus 1 terms in the GP. What the formula? A into 2 into r power 2 power. How many terms? Log n minus 1. R minus 1. 2 minus 1. Right? Fine. Minus log n minus 1 into 2 power log n. Right? Which will goes to minus S2 is equal to, what is the answer? This 2 power log n, approximately this area. This area, what is there? N is there. Minus log n minus 1 into 2 power log n, which will goes to n. Right? Now let's do, I don't want minus S2, I want S2. S2 is equal to, what is the answer? Forget about minus 1 plus 1. This is n log n minus n. So minus, I think comparing n log n and n log n better. So it will goes to, right, n log n. S2 is going to be n log n. Can you help me for the question number 33? What is the answer? B. S1 is n, S2 is going to be n log n. Many people know, only for namesake I done. Question number 33, only for namesake I done. S1 1 series, S2 1 series. Both contain AP-GP series. S1 finally giving answer n, S2 finally giving n log n. So answer for the question number 33, B. Instead of saying simply B, just only for namesake I resolve. Question number 33, answer is B. Go to the 34. Question number 34. 34, one recurrence relation is given. Tn is equal to T n by 5 plus T 3n by 4 plus n. If you solve this recurrence relation, what will be the answer? I think using recursive tree method you can solve. Can you say what is the first level? N. What is the second level? N by 5 plus 3n by 5. 3n by 4. Let me check. N by 5 plus 3n by 4. What is the answer? 20. 5 4s, 4n. 4 5s, 15n, which will goes to 19n by 20. I think problem is over. See, this is the answer. This will goes to log n base 5 levels. It will go to log n base 4 by 3. Log n base 5, log n base 4 by 3, which is bigger. Log n base 5, but log n base 4 by 3, which will goes to approximately, right? I think if the base 5, the base 5 it is going to be base 4 by 5. 4 by 5 means 1 point something. Base is small, more levels will come. So upper bound let me take. It will goes to log n base 4 by 3 times. Right? Series is like this one. What is the answer? 19 by 20. 19 by 20 whole power 0 n. 19 by 20 whole power 1 n. 19 by 20 whole power square n. It will continue. Lastly, 19 by 20 log n base 4 by 3 n. So if you see n common, 19 by 20 whole power 0, 19 by 20 whole power 1 and so on, 19 by 20 whole power log n base 4 by 3. It is the decreasing GP series which will goes to constant n into order of 1, finally big O of n. For the question number 34, answer is going to be n. So C is the answer. The thing what I done is recursive tree method I applied, because of many problems I said to you directly I done, right? So if you do log n base 4 by 3 times, because base 5 base 4 by 3 is bigger, upper bound I am giving, right? So this kind of series will come. Some people are asking how you know. First level cost is n, but second level cost 19n by 20 means okay, right? You know very well. Whenever first level, second level differ, series coming. Which series? 19n by 20. Before is 19n by 20. 19 by 20 whole power 0 n. Next to 19 by 20 whole square n. Right? Like that one GP series going up. But it is the decreasing GP series. Total sum is 1. Finally n. 34 answer n. Which is going to be C. Go to the question number 35. Go to the question number 35. Question number 35, right? Two things are given. Question number 35, two things are given. We have to match them. Let's check here. Question number 35. Two lists are given. Let's check. List 1, list 2. What is the list 1? M, N, O, P. List 2. U, V, W, X. Right? I think same reconciliation and solving. That only. Can you say what is the M? M is going to be T of N is equal to T of N minus 1 plus N. Which one? What is the answer for this one? So it is sum of n natural numbers divided n square. So M is going to be n square. Which option? I think W. W is going to be n square. So M is going to be W. Which option is there? Please check. M, W. I think 3 options are fighting. Let's go next one. What about N? N is going to be Tn is equal to Tn by 2 plus N. What is the answer? This will goes to N. Decreasing GP series. I think first term is the answer. This is going to be N. Which option? N. I think U. This is N. So can you help me know? N is going to be U. Which option? M, W, N, U. M, W, N, U. I think 2 options are fighting. Let's go further. What about O? What about O? Let's check. I think this problem, previous problem, almost similar story. Right? Almost similar story. Let's check here. Let's check. Can you help me know? What about the O? We done already this one. Tn by 2. Tn is equal to Tn by 2 plus n log n. This also we done previously. It is giving n log n. This is giving n log n. Which option is n log n? V. N log n. Can you help me know? What is the O? O is V. Which option? MW, NU. I think B and D one option. Next one 0V. 0V. I think answer is going to be D. D option. Until now D. What is the last one? What is the P? What is the P? Tn is equal to Tn minus 1 plus log n. This is also n log n. This is also n log n. According to D, what is the answer? At X, what is the X here? So D will be the answer for this one. But in the D, this is the case. Right? MW, NU, O is going to be V. Next one. P is going to be also V. Please be careful. PX no. Px no. Why? What is the x given? X given log square n, no relation. So this value becomes n log n. N log n is big O of log square n, no relation. No relation. So this is the answer. D. In the available one, little bit matching is D, but in the D change this. This one you change. Px there, not Px. Right? Pv. O also V, P also V. For the question number 35, answer is D, but in the D, P is V, not X. That is the 35. Go to the question number 36. Right, go to the question number 36. One reconciliation is given, we have to solve it. Which one of the following statements are true, they are asking. What is the reconciliation? Tn is equal to 2Tn by 2 plus root n. Right, let's apply master theorem. What is the Fn? Root n. What is the n power log a base b? N. N. Now can you help me one small line? E is bigger or not? N power log a base b bigger or not? Yes. How many time? Root n into root n. I think root n time. Root n is polynomial. Master theorem is possible. So what is the answer? Whoever is bigger is the answer. Who is bigger? N. Answer is N. For the question number 36, answer is C. So E is bigger, it's okay. How many time? Root n time. Root n is polynomial. Polynomial time bigger, polynomial time smaller, then master theorem is applicable, then whoever is bigger is the answer. Who is bigger? N. N is the answer. 36, answer is going to be C. Go to the next one now. Question number 37. Question number 37. What is the answer? Tn is equal to 2T root n plus 1. Right? This is the given reconciliation. 2T root n plus 1. This is the given reconciliation. Let me check here. Let me check. Fn 1. N power log a base b. n power log a base b. I think master theorem you cannot apply because there is no by. There is no by. I think extended master theorem you have to apply. What is the extended master theorem? You know very well. Let me check here. Extended master theorem if you apply, what is the answer? N is equal to 2 power k. That is the first assumption. What is the answer? Tn is equal to t 2 power k is equal to, what is the answer? 2 t 2 power k by 2 plus 1. I want to apply master theorem, but here b value I don't know. So I am going, right, this one, I am going, you know very well. What is that particular method name? If the recurrence relation contain root operator, once procedure is there, that procedure I am doing. If recurrence relation contain root operator, one procedure is there, that procedure I am doing. First step, assume n is equal to 2 power k, this one. This is the first step. See the second step, right, assume, what is the answer? T of 2 power k is equal to s of k, assume that. So simply these two will be same, remaining is s. Right, if you do that, what is the answer? S of k is equal to 2s k by 2 plus constant means 1. See, t there, s will come. Here there is no t, there is no s. Remaining places is there. Then using master theorem, solve it. What is the answer? Fk. What is the answer? Constant. Okay, next one. Right, in the place of n power, k power log a base b. What is the answer? K power log 2 base 2. So k. So I think master theorem is possible. So what is the answer for this one? S of k is equal to theta of k. Right, next one, that is the second step. Can you see the third step? Third step is going to be, right, third step is going to be replace, see, previously you replaced t by s, now s by t you replace. This will become, what is the answer? This will become t of 2 power k. See this one, s there, t came, here there is no s, theta of k. That is the third step. Fourth step, n is equal to 2 power k, first step, n is equal to 2 power k, right? Now reverse is going to be, n is equal to 2 power k becomes log n, replace 2 power log n base 2 is equal to theta of log n base 2, right? Which will become, what is the answer? The t of n, it will become theta of log n. So to this problem, answer is going to be, what is the answer? Log n. So after applying master theorem, what is the answer came? K. Whichever is bigger is the answer, k is bigger. So finally, replace s by t. Afterwards, n is equal to 2 power k, k becomes log n. So finally, to this problem, answer is going to be log n. Which option? B. B. For this problem, answer is going to be B. What is the number? Question number 37, answer is B. Using master theorem, directly not possible, indirectly possible. Indirectly how? If recurrence relation contain root operator, one procedure is there. I done that. 37, answer is going to be B. Go to the question number 38. Right. Question number 38. One recursive program is given. That program name is A of n. Assume that A of n time complexity T of n is equal to. And one more, in this recursive program, so many, right, if and else conditions are there. See this one, I think first box, that box indication that may be true, may be false. True, go right side. False, go left side. Right, next one more box is there, condition box, that is called condition box. Right, first condition box, right, condition true, you may go left, you may go right. Again, second condition also there, you, right, if it is right, condition is true, then return, otherwise go further. Again, third one also there. Can you help me one small line now? I think so many places condition is there. Some people are asking, if so many places condition is there, which side I have to go? Condition means may be true, may be false. Two paths are there. Which path I have to go? Right? If you observe clearly, what he is asking? See the problem clearly. Let me read the problem. The given diagram shows the flow chart for a recursive function a of n. Assume that all statements except for the recursive call have 0 order of 1 time complexity. In the worst case, he is asking worst case time. A of n time complexity T of n, it's fine. And one more, 3 conditional boxes are there, and he is asking worst case. If you want to worst case, find that path where many function call. More function call, more time. Remaining thing constant time. Only function calls will take more time. And one more, no loop also. Here no loop also. Here no loop, only function calls matter. Because of he is asking worst case. Take that path where more function call. Can you help? First condition if you see, if it is true, go right. otherwise go left. If you go left, only one function call. If you go right, two more function calls are coming. Again, second condition, if you see, true, return, false, one more function call. If you go to the third condition, true, return, false, one more recursive call. I think find that path where more function calls are there. More function call, more time. That is the meaning of worst case. Now see the answer. Tn is equal to, let's start the program. Start program. After a of n time complexity Tn is equal to, go inside, start. First one, an by 2. So Tn by 2. Afterwards, after Tn by 2 time is over, function call, after Tn by 2 time is over, condition there, maybe left, maybe right. Let's go right, more function call. What is the answer? 2Tn by 2, 2 function call. Afterwards again condition, maybe true, maybe false. True, then return. False, then function call. I want more function call, Tn by 2. Now again condition, maybe true, maybe false. True, return. False, an by 2. Again Tn by 2. So afterwards, I think the longest path, this is the place where many function calls are there. Afterwards you can stop, right? Constant time. No loop is there. Other than function call, no loop, constant time. You have to write constant. You have to say at this point of time, how much time? Constant. If you solve further, next levels will come. Right? Whenever nothing there, recursive call, recursion, that is okay. Nothing there, then write constant. If you don't write indication that you are saying that no time taken, no. Right? You done see many conditions you verify. Small things purpose, constant time. Recursive calls will take recursion time, that's okay. But small work, condition checking and all, that will take constant time at this level. Recursion means what? This level there, further recursions will take care. At this level, constant time because of lack of loop. If you solve this one, how many function calls? 1, 2, 3, 4. I think 5 function calls. 1, here 2 there, 1 more 2. Totally 5. 5Tn by 2 plus C. 5Tn by 2 plus C. Using master theorem, let me solve. What is the Fn? C. What is the n power log A base B? Which will become n power log 5 base 2. N power log 5 base 2. So I think this is a constant, this is n power something, I think it is a polynomial, time complexity this only, n power log 5 base 2, this is the answer. Right, just find out the log 5 base 2 value. He is asking, if the worst case time complexity of this function is n power alpha, then find the alpha value. Alpha value is log 5 base 2. Right? So in the log 5 base 2, just calculate whatever is the answer, that is the answer. Some people are asking me one small line. Why are you taking more function call? Worst case. Suppose some people are asking, if you want best case, then what is the answer? After start, an by 2, tn by 2, condition, true, false, true, go right, false, go left. Then only 2 function call, 2tn by 2 plus c. This is the worst case story. It is the worst case. Best case, Tn is equal to, what is the answer? 2Tn by 2 plus C, right, which will goes to order of n, it will become. If you want, you can verify. So worst case is n power log 5 base 2, log 4 base 2 is n square, log 5 base 2 more than n square. Best case is going to be only order of n. Go that path where less function call, best case will come. Go that path where more function call, worst case will come. So to this problem answer is, right, alpha value is log 5 base 2. If you want what is the log 5 base 2, just use in the calculator, you can find out. That is the question number 38. Next one, try yourself. Try yourself. You only say, it is the try yourself. Why should I try? It is the try yourself. Why should I try? But I am a nice human being, I am trying those also. Right? Thank you. So try yourself, I am trying the one problem. Actually this is your work. Why should I do? If anyone says you are not done and all, it is not my work. But still I am doing because I am a nice human being. So I am starting now. Try yourself. Can you say T1? What is the T1? F of n is equal to omega of n. G of n is equal to big O of n. And h of n is equal to theta of n. Maybe we done already this one, right? Anyhow, it will take very less time. f of n into g of n plus h of n is equal to what? This is the thing what is asking. Can you help me now? F of n is omega of n means what are the f of n possibilities? F of n is omega of n means what are the f of n possibilities? What omega means what? This side bigger. So f of n is omega of n means it may be n or more than n. Let me write minimum. Minimum is n. It may be n or more than n also. Minimum I written. Now can you help me one small line now? G of n is big O of n. What is the meaning? G of n is big O of n means n is bigger comparing with the g of n. These possibilities here, right? Possibilities here 1, 2, 3, see this one. Maybe constant, maybe log n. Maximum is n. Let me write minimum. Minimum 1. Next one plus h of n. H of n is always n. Now is there any chance of this person can increase? Yes, it may be n power 10 also, but I written minimum. It may be n also, but I written minimum. This is always n. This is always n. Right? Now can you help me one small line now? What is the answer I can write? Can I write here big O of n power 10? Can I write? Indication that comparing this side is n power 10 is always bigger or equal. Need not be, because this may be n power 1 lakh also. You cannot say this. It is not. Now some people are asking, sir, can I say like this? Can I say like this one? Omega of 1 can I write? Omega of 1 means what? Comparing left and right, left will be bigger or equal. Left will be bigger or equal, they are saying. Can I write or not? Omega of 1. Left will be bigger or equal. Of course, is n is there. Right? N. That may be this one. This is n, this is 1, that is okay. This is also n. Right? Omega of 1. This is always more than 1. That is also fine. Right? But one more nice way of writing, tightest one maybe, you can write like this. Because it is anyhow n. Some people are asking, sir, this side n power 10 possible or not? Yes, this is n power 10. Sometimes this may be n power 10 also, n power 10 into 1, n power 10 plus n power 10. Yes. So, you cannot write upper bound, you can write lower bound. This is also correct. This is also correct. Right? Please check. So, can you help me in the available option? Which option is right? What about option A? Omega of n. Option A, omega of n. Is it true or not? Yes. B, big O of n. No. C, theta of n. You cannot say always left and right both are equal. D, none of these. Answer is going to be A. Answer is going to be A. So, for the question number T1, answer is A. Some people are asking, sir, how can you say? This may be n power 1 lakh also, because minimum I written. This is maximum is n, it's okay. This is always n. He is the one who is deciding the story. He is the one who is deciding. Suppose assume that it is not omega, it is assumed that it is a theta. This is also theta. Then what is the answer? I think this is always n. This is always n. This is 1 to n keep on rotating. So it cannot go. At that time I can write theta of n. At that time answer is going to be C, theta of n. If it is theta, it is already theta, this is maximum is n, maximum, then I can write theta. At that time answer is going to be, right, A also true, B also true, C also. Best option C. Now here I cannot write C, I cannot write B also. Answer is going to be A only. For the T1, answer is A. Let's go to the T2. T2, some functions are given, we have to write in the ascending order and all. You can write, please verify yourself. Nothing, I think nothing special here. Please, you try yourself. T2 answer is, I think already is given, please verify. What about T3? Some functions, so T2 is saying that some functions are given, you have to verify which is bigger, which is smaller. It's okay. Can you go to the T3? What is the T3? One recursive program is given, you have to find the time complexity. So what is the answer? What is the function name? Find of n. Find of n time complexity Tn is equal to, inside if you observe, first loop, 4 times find of n by 2. Plus next one, what is the answer? Loop is going on n square time. So if you solve this one, Fn, n square. N power log a base b. What is the answer? This is also n square. Both are same. Then what is the answer? N square log n. Just multiply by log n. Answer is going to be n square log n. B is the answer. That is okay. T3 is also okay. Go to the T4. T4. One recursive program is given. They are asking what is the running time. Write the reconciliation and solve it. So what is the answer? Sorting of n element Tn is equal to. Sorting of n element Tn is equal to. Right? Can you help me? I think 3 function call. But one interesting thing is no loop, nothing. 3 function calls are there. Right? Please check every function. What is the first function call? Size. First function call size. Please find out. Low to T2. Low to T2. Let's check here. Low and high. If you have small doubt also, let's check here. Low to high. Assume that low is 1. High is 99. One array which contain low to high elements. Low is 1, high is 99. Assume. Now can you calculate T1? What is the T1 here? T1 calculate. Low plus 1 plus. High minus low plus 1. 99 minus 1 plus 1. 99. Right? So by 3. Which will goes toward the answer 33. It will become 34. Please check. Low minus high 98 plus 1 99 by 3. Which will goes to 33. 1 plus 33 34. That is the T1. What is the T2? Check. Low plus 1 plus 2 into high minus low plus 1. What is the answer? 2 into 33. Which will go to 66. Plus 1 67. So like that. Now can you help me now? What is the first function called? Sorting off. Sorting off. What is the answer? Low to T2. 1 2. 1 2. T2 means how much? 67 or 66. Whatever it is. Can you help me? What is the next function called? T1. What is the T1? 34 to high. High means what? 99. What is the next one? What is the next one? Low. 1 to T2. T2 means how much? I think first function call, third function call same. What is the answer? 67. I think if you observe clearly, here how many elements are there? Approximately. Total elements are assumed that n. Right? You are dividing into 3 parts, n by 3, n by 3, n by 3. I think if you observe clearly, almost like, right, double. Right? What is the answer? 2n by 3. It is also, if you want, you can check 2n by 3. It is also, if you want, you can check 2n by 3. Actually, n by 3 is 66. Plus or minus 1, don't bother. Right? So, 2n by 3, 2n by 3, 2n by 3. I think problem is over. What is the answer? Tn is equal to 3t 2n by 3. Plus, after function call, nothing there, constant. If you apply master theorem, f of n is equal to, what is the answer? Constant here. Next one, n power log a base b, which will goes to, what is the answer? N power log a, log 3, base 3 by 2. 2n by 3 is nothing but n by 3 by 2. Right? This one. So, I think if you see constant, this is going to be log 3 base 3 by 2. Log 3 base 3 is 1, then also polynomial. Log 3 base 3 by 2. 3 by 2 means 1.5, then also polynomial. So, answer for this problem is going to be, what is the answer? Theta of n power log 3 base 3 by 2. Whatever it is, just calculate, you will get the answer. So, this is the first chapter. So, I am thinking that most probably I helped you in few problems. Remaining all, I hopefully I am thinking that you done yourself. 1 or 2 places maybe I helped you. Still, if you have a small doubt also, you can ask your friends, you can ask me also. This is the first chapter.